Hey everyone, and welcome to Chef AJ Live. I'm your host, Chef AJ, and this is where I introduce you to amazing people like you who are doing great things in the world that I think you should know about. Well, today is the second Sunday of the month, which means it's time for Nutrition Insights with Dr. Peter Rogers. And today he's going to be talking about organics. Is it worth it? Let's find out. Welcome to the show, Dr. Rogers. You must spend all month between shows preparing for your presentations.
Oh, thanks. I really enjoy doing these talks. I wish I had more time to do them. I'm still working full time. I wish I could do this nutrition stuff full time, but it is what it is.
Oh, that would be great. Well, you never know. I mean, True North is always hiring.
Yeah, I know. I'd like to do it though. I'd like to stay where I'm at. I live in Illinois. I'd like to stay there if I could, because I saw they had a job and it would be great, but I'd have to move there. I'm not ready to do that yet.
A lot of people would love to move to California.
Yeah, it's nice. I think California's great, but I got family in the Midwest.
Well, move them with you.
Yeah.
Oh.
You know what I'd really like to do? I'll tell you what I really wish. What I really wish is I wish there were research institutes that really wanted to just find out the answers to the big questions. And I would love to do that. I have the personality. I would read, 10 hours every day. That'd be something I would love to do. But I don't even think such a thing exists, like a think tank for nutritional and health research and, anti-aging, longevity and all this stuff. Because, I'm the perfect kind of guy who would do that. I'm very much like McDougall. I enjoy reading and studying all day. And I wish you could get paid for that, but it is what it is. We all have things we wish for. So,
well, maybe you could start your own place.
Yeah, but I'm a nerd, a studier, a scholar. I don't have the charisma, the personality, the networking skills, the context. I don't got any of that.
Oh, that's what you hire me for.
You're great at all that stuff.
I'm not great at the science so much. Hey, there's a couple of questions that people submitted in advance. They didn't know your topic. So maybe when you're done with your presentation, if you don't mind, there's just two we could ask you.
Sure.
Okay.
Now I got to find, I'm on this other computer, so I got to find, where did my presentation go when I minimized it? Oh, I think I found it here.
Yep. Screen share.
There it is. Okay, now, I got a screen share in the Zoom.
You got to click the button, the green button.
Got it. There's a screen.
Why sometimes people start with it on.
I'll do desktop.
There you go.
Now I'm going to go into slideshow.
Slideshow, yeah, into view.
View slideshow. Yeah,
I see view. It's after meeting. I see view.
Yep. I know that's view, but it's not slideshow.
Oh.
It's a little different for me because this is not my regular computer. For some reason, there we go.
Oh, there you go.
Start from the first slide.
Now it's perfect.
Ready to go. Okay, I'm going to be talking primarily about, is organic worth it? But a lot of people have asked me specifically, they said, you're talking about cancer and you go on and on and on. Can you please limit it down and just give us a quick, concise summary? So I'm going to do a quick, concise summary before I go into the organic stuff. And this has been given different names. And I'm going to also share how I got my pattern of thinking. I learned more from these two guys than anybody else at Stanford. This is Dave Schultz and this is Mark Schultz. They're both world and Olympic champions. They were the coaches at Stanford when I was there as a wrestler. This is Stanford University. That's the Hoover monument there. These are the red roofs and the sandstone buildings characteristic of Stanford. These are the Palo Alto Bay Hills. And we used to run as a team sprints on these hills. We'd sprint up the hills. And one of the interesting things is when I met Dave, he's actually skinnier in this picture than he was when I met him. He was kind of fat and he couldn't run very fast. He was slow. And then we went in the weight room and he was kind of weak. And I was like, how did this guy who's fat, weak, and slow become the best wrestler in the United States? And his brother was also an incredible wrestler. Okay. He also was world champion, Olympic champion, 3-time national champion. So anyways, I learned a lot from these guys. And it also helped me to deal with the question I had for myself. And a lot of people have these questions. How can you win when you have no money? How can you win when you don't have much talent? Okay. And one of the secrets I've learned is there's different types of talents. A willingness to learn and change one's behavior, that is a great talent. Also, if you can learn a bunch of small skills, they can add up to become a great talent. And we're going to talk about how to do that. Okay, so here's Dave. He got the red singlet on, and I kind of matched that with the red text. Mark's got the blue singlet. I matched that with the largely blue text over here. So this is what I call the Dave Schultz School of Incrementalism, meaning that a whole bunch of little things add up. And so what this meant for Dave, when he was a kid, he was fat and he was dyslexic, and the other kids would make fun of him. You know, you fat, stupid idiot, you can't even read. And they would pick on him. His nickname was Pudge. And he liked wrestling and he kept practicing, diligently, and he got really, really good at it. He would ride his bicycle in junior high from the junior high practice to the Palo Alto Pali High school practice, and then he would go over to the college at Stanford University. When he was in junior high, he was going over to train with the college guys. By the time he was a senior in high school, he became the best wrestler ever in the history of the United States as a high school. He won the Open National Champion, pinning Chuck Yagla, the NCAA defending champ, with an arm throw. Okay, so the reason I tell you that is by adding up a whole bunch of little things, what he did was he mastered technique from all over the world. He taught himself how to speak Russian because the Russians were the best wrestlers in the world, and he traveled to Russia to learn how do Russian technique. Okay, that's the kind of personality he had. He was the best technical wrestler in the world. Like what Bruce Lee is to martial arts, that's what he was to wrestling. What I learned from, and so I'm going to show you how to apply that. Like me in school, I had never even taken an honors class. I was recruited as an athlete to Stanford. Then I was injured. I was all sad and afraid I'm going to flunk out. But I did what he did for academics. Everything you can learn about note taking, everything you can learn about memorization techniques, everything you can learn about study skills, everything you can learn about massively memorizing giant amounts of information. I studied all these memory champion contestants and whatnot, and I applied that to academics, and I found all the best people, and I got them to teach me what to do. From Mark Schultz, I learned intensity of purpose, and by that I mean he was so intense he frightened people. And usually a top-notch world-class competitor will often frighten people because they have a higher level of intensity that people are used to. And just like a typical thing he said to me, I had gotten injured. I was thinking about quitting wrestling even my sophomore year. And he came out to me and he said, "Pete, you shouldn't quit. You hang around with me, train with me. We'll run stadium stairs, and you need to hang around with wrestlers. You need to move into an athlete fraternity with other wrestlers. You should be talking about wrestling every day. That's how you get good. You got to focus your energy. Your opponent is your worst enemy in the world. He's trying to beat you up and embarrass you in front of your friends. You need to devote every ounce of your energy you have to fighting him." Okay, so I started hanging around Mark Schultz. I quickly became so much better. It's not even funny. I won 39 wins, set the school record, all-time record for victories in a season with Student Athlete of the Year award. So what I'm trying to say is these help anyone to be successful. This idea of incrementalism, learn every single thing you can possibly learn about what it is you're trying to achieve and be hyper-focused and intense, okay? Okay, here's Mark Schultz defeating Ed Bannock from Iowa, the two-time defending national NCAA champ. Mark went on to become a three-time champ. It's one of the greatest NCAA final matches. You can watch a YouTube video of that match, one of the greatest wrestling matches ever. Here's Dave Schultz representing the United States. And, he's got some little fat in his belly. And compared to the usual guys, world champion wrestlers, he's a lot less muscular. They usually got muscles on top of their muscles, okay? But man, was he an awesome wrestler. Here he is winning the Olympic finals against the German Nasp. And when you talk to Dave, what do I mean about technique? A regular college coach, you tell him, how do I finish a single leg from the feet? He's going to say you can run the pipe. It's called doing a dump. You could take the leg out high, do a treetop. Dave would know 20 other things. He would know how to trap the wizard arm. He would know so much technique. He'd go, here's the counter to the counter to the counter to the counter to the counter. That would end up being like a 2-hour or 3-hour conversation with him. And that's why he was the best in the world, because no matter what the other guy did, he had counters to the counter. So he exponentially knew more technique. You can only get about 20% better condition than somebody else or stronger, depending also on your natural ability. But man, you could learn 100 times more technique than another person. That was his secret. So here was me at Stanford, and this is a picture of how pathetic I was as a lonely freshman. I got this calendar on the wall. I'm counting every day until I can go home to see my girlfriend. I don't know a single person there. I got re-injured, so the coach was pissed off that he maybe wasted a scholarship on me. My girlfriend calls me, says she's wondering if it's okay. She was a year younger than me, to go to the homecoming dance with some other guy. I'm like, oh man, this is great. Does my life suck? I refractured my clavicle growth plate. So anyways, but what I did do that was good was I decided I'm going to become great at school. I was so sad and frustrated. I used to cry about not being as great a wrestler as I used to be. And by learning from Dave and Mark Schultz, this intensity and focus and obsessing over every detail, that's how I became a great student. That was my secret. Here was actually me in high school. This is all going to make sense. There's a reason why I'm showing you this. Trust me. It's going to be all related to preventing cancer and making you healthier. I have to go through this, though, so everything will make sense later. So this is when I took third in state, 39-1 in junior year of high school. That was my training partner. He's a 3-time All-American, World Cup champ, another national champion. All the guys I trained with were like these all-American world-class guy. So I was the low man on the totem pole, and that super motivated me. I go, well, if I can't be a great athlete anymore, I'm going to be a great academic. So it's rechanneling one's energy, Alfred Adler principle and Dabrowski theory of psychology. Okay, so what am I getting at? With regard to cancer, I think you can fight cancer in the same way. This is Hannibal, the great Carthaginian general who kicked the crap out of Rome. Here he is with this urn full of rings of Roman soldiers, and he had a lot of them. He killed many, 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 many thousands of Romans. All of Rome was terrified of this guy. Okay, he was one of the greatest generals of all time, Hannibal. Then they hired somebody in Rome named Quintus Fabius Maximus, who had a strategy to deal with Hannibal. He knew he could never go head to Hannibal, but he could destroy Hannibal's supply lines. And through that method, he figured out how to deal with Hannibal. Okay. And he was a guy who eventually defeated Hannibal, because Hannibal was far from home. He's from Carthage, and he's out hanging around Rome, traveling around the continental Italy. Okay. So that's called the Fabian strategy. You want to know that, because we're going to use a modified version of the Fabian strategy. And that relates also to Napoleon. Here's Napoleon, another one of the greatest generals of all time, a badass, just like we think of cancer as being a badass. And he went over the Alps to conquer. And now Napoleon went into Russia. And Napoleon had a problem with Russia because it's so darn big. And what the Russians used was a modified Fabian strategy, a scorched earth policy. And I'm going to call this the poor man's strategy of fighting cancer. So basically, Napoleon said an army travels on its stomach, and he would just take the food from the neighboring people in the villages. And guess what? The Russians said, no, you're not going to take our food. They would burn down all the crops, and they would take all the food out of the villages. So Napoleon came in there with over 500,000 men. He left with about 15,000. Okay. And so in a sense, this is what we're going to talk about doing to cancer. Cancer comes in all bad and scary, and we're going to try to just deplete cancer of all the things that it needs, and thus prevent it from growing and conquering. Okay, so here's the main phases of cancer. There's initiation, and nobody can change that. That's previous DNA damage, and it can be due to so-called somatic mutation theories, what's taught in the schools. What I actually think is correct is the hypoxic theory of Warburg, okay? But you can't change some DNA damage you had who knows how many decades ago. What you can focus on is how to avoid things that promote tumor growth. And the tumor promotion is where we win the game. And of course, you avoid animal protein. There's a bunch of other things you can avoid. We'll talk about that more in just a moment. And also, you want to prevent metastases from taking hold in distant locations and from growing. So this is a model of understanding tumor growth. We talked also about a cancer cell being different than a normal cell. A normal cell is a worker. A normal cell has a job every day. Okay, the liver gets up in the morning, and it has to detoxify stuff. It has to make bile. It has to maintain blood glucose level during fasting. So that's the job of a liver cell, which requires tons of energy production. Energy production is the main task of a normal cell. It's a worker. Cancer cells are different. Cancer cells have been hypoxic. Their mitochondria don't work so well. The cancer cell's job is just to live. It's like it turns itself into becoming like an anaerobic bacteria. It just wants to replicate and to grow. And it also is kind of like that song, Johnny Paycheck, take this job and shove it. It's not interested in doing any type of work. It just wants to replicate. Because it wants to replicate, it doesn't care that much about making ATP. What it cares about is synthesizing copies of itself. Because in order to replicate, a cell has to double its contents. It has to make twice as much protein, twice as much nucleic acids, DNA and RNA, as well as lipids and plasma membranes and all the organelle membranes. Okay, so that's a different focus of cancer, and this model is important for understanding how cancer works. By the way, as scientists, scientists, we love our models just as much as the artist does. Okay, this is the Pygmalion painting of Jean-Léon Gérôme, okay, 1890. And it's a common fantasy amongst male nutrition experts that they can teach a fat lady with a nice personality how to lose weight, and she falls in love with them. But in real life, once she gets all skinny and beautiful, he loses interest in the nerdy nutrition expert. Okay, well, anyways, here is a normal cell. Like we said, it's a worker cranking out energy through oxidative metabolism, ATP in the mitochondria. Anaerobic bacteria just runs anaerobic glycolysis, gets only like 2 ATP per glucose, whereas when you go through the mitochondria, you get like 36, so 18 times more. So anyways, here's what cancer does. Cancer has some unique metabolic features. First of all, cancer can run on glutamine. It's amino acid. It can run through the back door on this amino acid, from protein, amino acids. So that's why the whole keto thing, I think it's bogus. I don't think there's any way you're going to get that to work. And I know there's so-called keto inhibitors, but I don't think you can make this work, okay? We're not going to go into that too much now, but I'm just letting you know that's a real issue. All right, iron, there's increased iron receptors. These are transferrin. Transferrin is the blood transport protein for iron. So you can have 100 to 1,000 times more of these iron transporters on the plasma membrane. Okay, it also needs to take up a lot more fat. The point is, if you deprive the cancer cell of iron, it can't grow. That's how we prevent bacterial infections from progressing, by sequestering iron away from them. So keeping a low serum ferritin level can be very helpful. I'd probably recommend keeping it definitely below 80, and potentially between 25 to 50 is probably the perfect location based on the Leo-Zacharski data. The cancer cell also wants to create an acidotic milieu. It pumps protons out into its extracellular matrix, and that impairs the growth of the adjacent cells. So cancer sort of takes over the neighborhood. It's like a gang of thugs that take over the neighborhood, inducing this acidosis. This acidosis locally in the milieu also impairs the immune system, so the immune system cannot remove the cancer cell. Okay, so this is going to be, those are real important points about how cancer works. It also has IGF-2 receptors, insulin-like growth factor receptors, okay? And when mTOR is going to be the nutrient sensing pathway that really activates cancer. Okay, when a cancer metastasizes, it has to form attachments to the target organ that it goes to. So let's say the cancer spreads from the kidney to the liver. It's going to have to attach to the liver. And it has a much better attachment chance to the liver if the liver's endothelial glycocalyx is not intact. I'm going to explain how that works in just a second. Okay, so here's a sample of a cancer cell. So cancer cells traveling through your blood, it wants to land. But this is called the glycocalyx. Glyco means sugar, calyx means coat. So there's a sugar coating on every cell. I'm going to explain the chemistry of that in a few slides from now. But the important point is, if that glycocalyx is intact, cancer cell can't land. But if because of inflammation or a lot of dietary sodium or other toxic foods, this glycocalyx is depleted, and glyphosate depletes that as well. We're going to talk about that with regard to non-organic food having more of that. Then the cancer cell, the receptors are located. So these little curvilinear black structures here in this picture are called adhesion receptors for binding to white blood cells and cancer cells. Normally, the glycocalyx blocks them away. It has a negative charge. This has a negative charge on it. They repel each other. But when the glycocalyx is diminished, now the receptors are exposed, and the cancer cell can bind and enter the target tissue and then spread, let's say, the kidney cancer spreading to the liver. Okay, that's how it works. So that's why you want to maintain an intact glycocalyx. If you keep this intact, the cancer cell can't break through and attach here and spread into this target tissue. Certain things that damage the endothelial glycocalyx include hypertension. Hypertension becomes relevant at bifurcation points. So you'll have one branch of the artery going this way, one branch of the artery going this way. When it hits against the median divider here, you get turbulent blood flow and you get these retrograde eddy currents. These retrograde eddy currents and the turbulent flow, they confuse the endothelium at this location, and that will cause shedding of the glycocalyx with exposure of the underlying, shorter in height adhesion molecules. I'm going to go through all this in much more detail, but I'm just making the point. Hypertension damages endothelial glycocalyx at bifurcation points and provides a spot where atherosclerosis can develop or where cancer can spread. Okay, the big picture in preventing cancer is you want to try to spend as much of your life as you can in a maintenance phase. And so what that means is, for example, maintenance means the body's sort of restoring itself. It's not trying to grow. You grow when you're a teenager, during puberty from, let's say, 12 years old to 20 years old. Okay, but then you don't need to keep growing when you're older. You don't want your cells replicating that fast. All right, so the growth phase is characterized by nutrition overload, too many calories, especially lots of protein and fat available, obesity, high cortisol levels. mTOR is a mammalian target of rapamycin, a nutrient sensing pathway. It's like a contractor. When it has enough nutrients, it says time to build, which means time for a cell to replicate. If you have cancer, you don't want mTOR being activated because it tells the cell to replicate means cancer to grow. So cancer is highly dependent on a couple things. It needs iron to grow. It needs leucine. Leucine is by far the most important of the amino acids in terms of it being a rate limiting step for activation of mTOR. Okay. Excess dietary fat can also cause activation of mTOR. Insulin resistance, like in diabetes, causes activation of mTOR. Insulin-like growth factor goes with insulin. Okay, animal protein, we talked about that because animal protein has a lot more leucine. Plant protein is much lower in leucine. Animal protein also has a lot more methionine, an essential amino acid necessary for cancer to grow. Estrogenics will cause proliferation of estrogen-dependent cells, which tends to be the case with breast cancer most of the time, about 90% of the time, and also with prostate cancer. Excess dietary sodium increases cancer risk for several reasons, one of which is that it impairs, it damages the glycocalyx of the endothelium, making it easier for metastases to spread, okay? Excess sweets usually means excess high fructose corn syrup, which predisposes to fatty liver and things related to that. Versus when you exercise, you lower your energy level, so you activate this pathway here. AMP stands for adenosine monophosphate, sort of like ATP is adenosine triphosphate, the energy currency of a cell. So AMP means the cell has a low energy phase. So it's the AMP, activated protein kinase pathway. And what that means is after you exercise, you're tired. You've depleted your energy stores to some extent, and you have to rebuild them. So that shuts off mTOR. Remember, mTOR is like, okay, we've got all the building materials we need. Everything is good to go. We got all the nutrition you could ever want, tons of energy. Let's build. Whereas this pathway is like, hey, we're low on energy. No active growth at this time. Let's just restore our baseline energy level. Okay, of course, complex carbohydrates are the best. Fruit, vegetables, and starch, staying thin, getting adequate sleep. Melatonin is also an antioxidant, as well as, helping us to sleep. Love gets oxytocin hormone. All of these things improve immune function. Having a dedicated purpose in your life, sort of what you feel God meant for you to do, whatever you feel is sort of why you were put on this planet. Religion can help people, and gratitude helps, an attitude of gratitude. Okay, exercise is also good because it makes you smarter. An interesting thing is a sea squirt and its characteristic lifestyle. By the way, Voltaire had asked the question, why do animals have brains but plants do not? Because animals move. And what is the purpose of a brain? To be able to walk down a path in a forest or a jungle or a prairie and to survive, okay? As soon as you start moving, you got to do some thinking. You got to decide, what is my destination? So you have to have value judgments. That looks like a fruit tree. I shall go over there and get something to eat. That looks dangerous over there. There's a bunch of coyotes over there. I will avoid that, okay? How do I find my way back? Okay, there's all these things you have to know. And then how do you avoid obstacles in your path? So you have to have a brain and think if you're going to be moving around. The sea squirt during its juvenile phase swims around, so it has a brain. So it looks like a little tadpole. When it's an adult, it attaches to a rock, becomes a filter feeder, and its brain is reabsorbed. So the point is, if you're sitting around like a filter feeder, a couch potato watching TV, you don't need a brain. So you got to keep moving. You got to use your brain. You have to do it actively to maintain brain function. Okay. The other thing is social thinking is good for going to a party, everything in moderation, go with the flow, get along with people. Yeah, that's fine. But for nutrition and health, you don't want to think that way. You want to think biblical. Okay. You want to think 10 commandments. Thou shalt not eat meat. Thou shalt not eat oil. Thou shalt not, do all these other things that are bad for your health, and you'll do the things that are good for your health. You want to be 100% committed to them. Just like Rocky, Coach Mickey, and Rocky said, I'm tired. Why don't we train tomorrow? Mickey said, no, there is no tomorrow. You got to train today. So, do the things that help you, avoid the things that don't. You got to have this intense commitment. And it's good to look at role models who've been helpful. Ruth Heidrich, fantastic recovery from metastatic breast cancer. She's only 40. She ended up living into her 80s. She's still alive and still going strong. Janet Murray Wakelin, another interesting lady who survived metastatic breast cancer, I think about 23 years at this point. And she ran marathons all around the perimeter of Australia with her husband. She ran a marathon every day for an entire year, 365 marathons. Ruth Heidrich, of course, does all the triathlons and marathon, won all these medals and was like a world record holder. So the point I'm saying is I've seen this as a pattern. A lot of people who've had incredible survival, they call these super survivor persons, they exercised a lot. Sunshine is also very good for our health. Another thing that's real pleasant is just going for a walk on the beach barefoot. That's all that grounding and the negative charge and stuff. I think there's something to that. I mean, how useful it is, I don't know, but I do think there's something to it. I think the reason why we feel so good when we go for a walk at the beach is the sunshine activates nitric oxide precursors in our skin. So we get this sort of diffuse bodily vasodilation, which is a very pleasant feeling. It also increases sulfate production. And a lot of people are sulfate depleted, especially if they're eating this non-organic lipophosphate. I'm going to explain why in just a little bit. But these are all things that promote health. Okay, now it's also good to learn more about cancer. For example, T. Colin Campbell, he deserves a Nobel Prize for figuring out how animal protein is such a powerful causative factor in cancer. I studied how can meat cause cancer. I came to like 32 ways before I stopped counting, okay? So he's got video lectures on that. Dr. McDougall, of course, a magnificent nutrition doctor. He's got a whole bunch of lectures on cancer. This lady here, Kelly Turner, wrote a great book called Radical Remission. Here's the name of the book, Radical Remission. She was working at Harvard at one of I think the Sloan Kettering or something cancer center. And she had noticed there were some patients who had incredible survival of metastatic cancer. And so she studied them. She went around and studied all these people who'd survived metastatic cancer and how they did it. And then she wrote a book about it, the 9 factors. And she had a follow-up to that book where she added one more thing, which I think was exercise. But anyway, so she's got some good information on that. I think she hadn't quite gotten to 100% vegan, but when you study it, you end up there. There's a good reason why T. Colin Campbell, 100% vegan, Dr. McDougall, 100% vegan, and myself, 100% vegan. I also have lectures, a bunch of lectures on cancer. I have a whole playlist on cancer. And there's a lot of other people, cancer super survivors like Chris Wark. He's got interviewed a whole bunch of other cancer super survivors and experts. So the point being is you can educate yourself pretty quick. The cancer's probably been around there for decades. So you've got some time to figure this stuff all out before you rush into any aggressive treatment, before you're sure you need it. The other thing is it's good to have a sense of humor. Having a sense of humor is a way that we sort of put ourselves at ease. It's enjoyable and it lowers our stress level. And so, here's a classic picture. This is Plato, the great Greek philosopher. He was kind of pompous. And for example, Plato was asked to define what is a man. And Plato said, a man is a featherless biped. So Diogenes, who was sort of a clever, fun philosopher, also from Athens, he said, well, here is Plato's idea of a man. And he plucked a chicken and said, behold, Plato's idea of a man. I thought that was kind of funny, a featherless biped. Okay. Also, it's good to spend time with the people you love and the people who love you. So there's a nice painting, Homecoming by Edward Moran. Spend some time with family, friends, and loved ones. That makes you happy. I'd say don't do things that are trivial or a waste of your time. Focus your time on the things that matter and the things that you enjoy. Okay, Dr. Caldwell Esselstyn, he said to eat green vegetables 6 times a day keeps your arteries bathed in nitric oxide. And where that comes from is, as people get older, they make less nitric oxide. Now, I would debate that just a little bit in the sense that in a population eating meat, processed food, and oils, they're going to be making progressively less nitric oxide. I don't know, though, for sure how much nitric oxide diminishes in a healthy population that's eaten, low-fat vegan for many, many years. Because in the populations that eat that way, they got the same blood pressure as teenagers as they do in their 70s. But be that as it may, most of us will probably benefit from eating more greens during the day. And if you want to go all the way to the max, Dr. Esselstyn likes 6 times per day. I still haven't seen the paper that proves that, but he's been promoting that for about a year now. And I think he's another guy who deserves a Nobel Prize for his, figuring out how to reverse coronary artery disease. Amazing stuff. I actually went and trained with him for a while. I'm very impressed by him. Okay. And he makes some interesting points. He says coronary artery disease is non-existent essentially in Tarahumaras. They're in northern Mexico, Papua New Guinea. They eat about 93% of their calories from sweet potato. Okinawa, they used to eat tons of calories from sweet potato, but they've kind of been pushed towards more of a modern diet, and they're not as healthy as they used to be. Central Africa, the Okinawa is like in southern Japan. It's kind of like what Hawaii is to America. That's what Okinawa is in Japan. Central Africa, in Kenya in 1929, they did a study where 1,800 consecutive hospital admissions, and there wasn't a single hypertensive patient. Okay. Rural China, also incredibly thin and healthy back when they used to eat the rice diet. So that's the perspective of Esselstyn, how it relates. So here's what happens. You eat a plant and the plant's got nitrates. Then there's bacteria on the back of the tongue, and they'll convert the nitrates into NO2. And so then that goes down your esophagus, down into your stomach, and then the stomach acid converts it into nitric oxide, just NO, nitrogen, oxygen. And that is absorbed into your arteries, and that travels throughout your body, causing vasodilation, opening up arteries. That's what you want. And you want to avoid some of these toothpaste and whatnot and mouthwash because they can impair, they'll kill off these bacteria on your tongue, and then you won't be able to make this conversion, and you'll lose that opportunity to make nitric oxide. So you can see what I'm saying is as you get older, your arteries make a little less nitric oxide, but eating the greens provides you with more nitric oxide. Getting sunshine on your body provides you with more nitric oxide. It's a way to keep your nitric oxide levels high. Another thing I think you want to be careful about is air pollution. I think this is under-recognized. There's been a change in the pattern of lung cancer. Lung cancer used to be primarily squamous cell carcinoma, but we see more and more adenocarcinomas, and some of the great pulmonologists have told me they think it is due to increased exposure to air pollution. Anything that smells bad is bad. Okay, there's a reason why God gave us a nose. If it smells bad, it's bad. So try not to live near, a real busy street if you can avoid it. I won't even eat like at a sidewalk cafe next to a busy street. I don't want to smell all that stuff. Plus, you got cadmium coming off the brake pads, which is a mitochondria inhibitor. It's kind of toxic. In your house, you might want to get a HEPA air filter. Maybe you can't move and you live in a kind of a polluted area. You might want to do that. But just being aware of it, air pollution is worse than people think. So any type of factory or anything, you want to try to avoid that if you can. So I think that's one of the things to watch out for, because there's some people who've gotten lung cancer that don't smoke at all, And I'm going to bet you that there's a good chance air pollution contributed to that. Okay, so I just wanted to have it all on one page, an anti-cancer checklist, so people could see it all on one page. And this is just educational information. It's not medical advice. I'm not your doctor. I'm just providing education, so this might be helpful to you. Okay, no meat, not one bite, because you get rid of so many things. Like I said, meat is the most powerful thing to increase cancer risk. In more than 32 ways, it increases cancer risk. And what's his name? T. Colin Campbell had the same observation. Every time he checked a problem with meat, he kept finding more and more. I heard him lecture on like 10 of them. Okay. I think you probably would be wise to decrease your overall dietary protein. I haven't read that. That's not official, but just my thinking about it, you know, beans are like 25 to 30% protein. So that's a lot of protein. So I would probably minimize that. You really don't need much protein. You know, human breast milk is only 5% protein during our most rapid growth phase of life. And there's been populations where you feed these starving people 2.5% protein. They do great. So it's impossible to be too low in protein. I wouldn't worry about it. No dairy, because dairy increases insulin-like growth factor, which is a tumor promoter. It also tends to be high in estrogenics, a tumor promoter. You got to filter your water at a minimum. You want a carbon water filter to get rid of the estrogenics and some other things. I ideally would use reverse osmosis because you also get rid of this F- stuff. And I think that gets rid of aluminum as well. I would have a whole house carbon water filter, and I would have a kitchen reverse osmosis filter. Minimize your dietary fat. Again, it's impossible to be too low in fat, in my opinion, based on study of the subject. And McDougall would agree with that. Pritikin would agree with that. I've read these studies where they would feed people 0.75% fat, less than 1% fat. So we're not going to go into that too much, but I'm just telling you, I think it's pretty safe, and there's a lot of research to back that up. Pritikin's exact words are, it's impossible to be too low in fat with any naturally chosen diet. Okay, no oil. I think all the oils are bad. That's what I would do. I would avoid them. I did mention possibly having a HEPA air filter, or try not to live near a place with toxic chemicals. Avoid toxic chemicals in general, okay? I don't like chemicals. Like I said, I have a nose for a reason. If I smell something bad, I want to walk away from it. Like if I'm peeling potatoes in the kitchen and one of my family members is doing the dishes and they open the dishwasher, I hate that. I smell all the soap and I go, don't do that. And they go, oh, stop it. You're autistic. You know, go over by the table. I'm like, well, I got better light right here next to where the dishwasher is. Please don't do that when I'm in the kitchen. But be that as it may, pay attention to your nose. There's a reason why you have it. Okay, minimize salt. Salt, you know, is a vasoconstrictor. It damages the endothelial glycocalyx and inhibits endothelial nitric oxide synthase, so you can't make your vasodilator, which means you constrict your arteries, causing tissue hypoxia. That's bad. All this dietary fat lowers oxygen delivery to the tissue too. That's bad, because when you lower oxygen delivery, you're pushing towards a Warburg effect, whereby the mitochondria can't get enough oxygen and the cell is pressured to potentially shift to anaerobic metabolism, which can transform it into cancer. You don't want that. Chlorine of salt displaces bicarbonate, which can cause a mild metabolic acidosis, and that will favor a cancer milieu. Acidosis and hypoxia, they favor cancer. So the worst thing to do would be eat real salted meat. Okay, that would be stupid. All right, so lower serum ferritin. Definitely want it below 100, preferably less than 80, and probably the perfect spot to be would be 25 to 50. And then some people say if you go below 25, you risk having restless leg syndrome. But a lot of women, especially, they run serum ferritins lower than 25. So it just depends. Because then you keep that iron away. What you're really trying to do is minimize free iron, which could be causing oxidative stress and which cancer needs to grow. Okay, that's why you do that. We talked about the best diet. Everybody knows that. Just watch Chef AJ or me. 100% vegan, whole foods, 100% organic, low fat, low sodium, no MSG, no MFG, no caffeine, no alcohol, no tobacco, no sweets, no foods with greater than one ingredient. All right. Tobacco obviously is a cancer causer. Alcohol is too, not even one drop. I wouldn't drink even 1 cup. I think it's toxic stuff. Okay. Sweets, usually that's going to mean high fructose corn syrup and all the issues, potentially contamination with mercury. Okay. Fruits are alkaline. That's good. Alkaline gives a more favorable environment for the normal cells over the cancer cells. Maybe consider eating Esselstyn's green 6 times a day. Get more nitric oxide, get more sun because it optimizes vitamin D. Much better to get it from the sun than from a pill. Increases nitric oxide. It also increases a good type of sulfation to endothelial glycocalyx. We're going to talk about that more in just a moment. Get your sleep, manage your stress, because that lowers your cortisol levels. You get better immune function. You sleep better. Laughter and comedy lower stress level. They're a very good thing. Exercise, it shuts off mTOR. That's the big thing about exercise. And it gets all your lymphatics flowing so that your white blood cells can better travel around the body to remove metastatic cancer cells. So that really helps. Okay, stop doing the things you don't want to do. Don't waste time with trivia or distractions. Consider retiring from your formal job so you got more time to focus on healing. A little bit that's what I meant by the Mark Schultz concept of intensity of purpose. What I meant by the Dave Schultz incrementalism is all these things, each one seems small by itself, but they add up in a powerful way. If you slow the cancer growth by 50%, you just double the amount of time you're going to live. Slow it by a little bit more, you can triple, quadruple, and keep on increasing the amount of time that you live. Forgive the people who mistreated you in your past for your own sake, so you don't waste energy on resentments. Better to have an attitude of gratitude for what you've had. Like some people ask me, why am I so happy? They go, you got all your problems. I go, yeah, I got problems, but I'm only half screwed. A lot of people are totally screwed. I see all these patients all day. They're so end stage in their sickness and they're cognitively impaired. That's real bad versus I got little minor problems. Okay. I'm perfectly happy to deal with those. I'm pretty lucky for what I have. That's how my thinking works. And that attitude of gratitude is a good thing. Okay, spend more time with the people you love, with positive people that you feel encouraged by. Make an audio or a video summary of your family history for your kids, your nieces, and your nephews. It helps children to have some history from their families told to them. That really helps them to grow up wiser and have better perspective and a better sense of their own identity. Focus your time on the things that matter, your purpose in life. Help other people. That makes you happier as well. I think it releases reward neurotransmitters that just make us happier and improves longevity. Religion is very helpful to a lot of people. For example, I love Christian art and music. You find for yourself what helps you in that area. If it works for you, a lot of the longest lived people have felt that religion was very helpful to them, and family and community. Read and watch videos of other super survivors, like we showed some pictures there. These are all some of the super survivors in some of their books. So check those out. If possible, find some way to track your progress. For example, if you have prostate cancer, you can often track it by following your PSA, prostate specific antigen. If you're, going low fat vegan, like the Orna study it showed, the ones who all went vegetarian and, reduced their stress, they kept their PSAs same or lowered them. Okay. Versus the people who didn't had a tendency to raise them up and had to go for surgery or chemo. So sometimes you can follow your progress with CAT scans, for example. Sometimes you can follow just on how you feel. These are all indicators of how you're doing. Okay, so anyways, that's what I wanted to say about cancer, and it's a segue into now I'm going to talk about should you eat organic or not. Okay, and I would say yes, you definitely want to eat organic if you can. And now I'm going to go into some of the reasons, and if you can't do it, there's ways to at least make the most of the non-organic. Okay, first of all, sunshine increases sulfate, a good type of sulfate, in the arterial lining of the endothelial cells. So sunshine is good for us in a lot of ways. It's sort of like the way we were designed was kind of smart. Just like a plant gets energy benefits from the sun, we do too. Sulfate in the form that's in arteries is what's called cosmotropic, meaning that it causes water to gel, to become like jello. I'm going to explain why that's a good thing. It'll make sense here in just a moment. I'm just introducing you to the term. Okay. The enzymes in the liver for detox, cytochrome P450 enzymes, the glyphosate can damage those enzymes. I'll show you what this is all about too. Oh, this book didn't really print out so well, but there's a lady by the name of Stephanie Seneff, and she's really the one who's world famous for her research on all the problems with glyphosate, and her book is called Toxic Legacy. The best book to introduce you to the blood viscosity is this one by Gregory Sloop, MD. I think he's the best researcher in the world for atherosclerosis. And this concept, and by the way, I did a fellowship at Harvard in vascular interventional radiology. So, excuse me, I've been thinking about vascular disease for over 25 years in great detail. This is the best book I ever read on atherosclerosis, and he's the best researcher that I've ever come across. And I think the reason is he's a pathologist. Pathologist, he doesn't care. You see, if you read a book written by a surgeon, the surgeon has to say that surgery is good. If you read a book written by a cardiologist, they have to say that stents are good. And they have to kind of go with convention or people get pissed off at them, okay? If you read a book by an internist, they got to say that drugs are good, okay? But if you read a book by a pathologist, he doesn't care he just wants to understand atherosclerosis, okay? And he looks at it under a microscope, all right? So he sees it in front of him every day under a microscope. So he knows what he's talking about. And it matched up his findings with what I see all the time when I do arteriograms myself or when I look at CT angiograms, MRI angiograms, etc. Okay, fourth phase of water. This is a very interesting book by a guy named Gerald Pollack, and he figured out that water has 4 phases. Everybody knows about the solid phase, that's ice. About the liquid phase, that's bulk water. About vapor, water, dissolves as a gas into the air. But there's a 4th phase where it's like gel, like a jello. Okay, so here's a better picture of the book. This is the lady, Stephanie Seneff, PhD. This is her book, Toxic Legacy. I abbreviated TL. I'm going to make reference to page numbers from this book. pretty dense biochemistry book. She also has a bunch of online lectures, if you're curious about this subject, where she goes into great detail. Okay, so first of all, one reason why I think it's a good idea to eat organic is there's a lot less pesticides in the urine of people who do this. So this one studied 13 different pesticides in their metabolites, and the ones eating organic were far lower in every one of them. So that's the green. See, look at how much lower they are right here. Here's the reference. I'm going to give you these references. If you want, you can look them all up, but there's a lot of papers that show this. Here's another one. 5 times lower pesticides in the people eating organic. Okay, and these are pesticides. We're not even talking about herbicides yet. So there's a big advantage in terms of pesticides. Pesticides are like things that kill insects. Herbicides are things that kill plants. Okay, so here's somebody, they ate an organic version of the Mediterranean diet, or they ate a non-organic version of the Mediterranean diet. 91% less urine pesticide excretion when they ate the organic version. Okay, so those are big benefits. Within 6 days, they had let's say an average 75% drop in their urine, glyphosate, and this metabolite of it. So those are impressive numbers. So there is a reason to do that. And I go through that because I've had some friends and family members say, oh, organic is BS. You know, they cheat all the time. And I don't know how often they cheat, but certainly every time they test it, it's been proven that there's far, far lower pesticide residues. And there's also going to be a lot less herbicide exposure, as we're going to talk about, especially to glyphosate, and to atrazine. The other thing that comes up is GMO. This guy right here, Jeffrey Smith, he's probably the most famous in the world GMO expert. And he jokes, he says, keep the genie in the bottle. So remember that TV show, I Dream of Jeannie? I used to like watching that when I was a kid. Okay, he says, keep her in the bottle, so to speak. You don't want this. If you can avoid GMO, avoid it. Who the heck knows what it does? Here's one of his books. That's one of his older books. He's got newer books on the subject. He's got a whole bunch of online videos. The other thing, too, you hear, oh, well, we need GMO because it's going to have better crop yields and save the world from starvation. That's not true. Here's a paper showing they get just as good of yields from organic farms as they do from the sort of conventional big scale farming with this GP stuff. And the claim was it was going to reduce how much herbicide gets sprayed on crops. But what's happened is the weeds have become largely resistant to it. So now they spray tons more, and they have to add a bunch of additive chemicals to it to make it more powerful, which also makes it more toxic. And we don't even know what a lot of those toxic additive chemicals are. In terms of making your body more powerful to resist disease, you want to have an intact gut. The gut's only one cell thick. It's lining, the enterocyte. Gut's the enteric tract, so enterocyte's the lining cell. Also, your gums. That's where you contact the outside world with your mouth and your intestinal tract. So you want it to be intact. So bad stuff like bacteria and their toxins don't get inside of you. Your blood is also highly relevant to all that. You can get dormant bacteria in your blood. We talked about that in the last lecture, especially the one about autoimmune disease. You also need to have this lining of your arteries. It's called a glycocalyx. Glyco, sugar, calyx coat. Sugar coat. You want that intact. And there's a lot of things that'll damage it. Pretty much all the things you would expect. Diabetes, hypertension, smoking, etc. Okay, and inflammation, infection. Okay, and the way you keep it in good shape, good nutrition, and get sunshine, all right? Leaky kidneys. When you lose this glycocalyx, you'll start leaking protein out of your kidneys. Major finding in diabetes, albuminuria. Okay, leaky blood-brain barrier often goes with the things that cause leaky glycocalyx or leaky gut, all right? Not as common, obviously, but it's a big deal. All right, fourth line of defense, your immune system. There's things you can do to maintain a good immune function. Blood-brain barrier, liver detox. You want the liver detox to be functioning. It's almost like called an immune system for small molecules. And you can also excrete things through your kidneys and through your sweat. Another good thing about exercise, when you sweat with your exercise, you excrete toxic metals, so that's a big benefit. Most energy in the human body under normal conditions is made right here in the inner mitochondrial membrane. These are the electron transport complexes, big proteins, and they pass electrons down to progressively stronger electron attracting molecules. And oxygen is the ultimate electron acceptor. It has a super high electronegativity, the highest electronegativity except for F-, and F- is toxic to the human body. So we're just going to talk about oxygen, and it takes those electrons and it's converted into water. So anyways, this is how it's all supposed to work. These are like a fireman bucket brigade handing those electrons down until they reach oxygen, okay? And glyphosate is going to be abbreviated GP. It inhibits complex 2, which is succinate dehydrogenase. It's actually part of both Krebs cycle and the inner mitochondrial membrane electron transport because it's embedded in the membrane, all right? So you want to know that. So GP itself is harmful to electron transport in the mitochondrial membrane. So it's going to make it harder to produce energy, harder to produce ATP over here. Okay, and the relevance is there's a whole bunch of other things that will also inhibit Mitochondrial electron transport, cadmium, excessive dietary fat, especially saturated fat, lead, we talked about F minus, HNE, hydroxynonenal, that's a toxic byproduct of eating omega-6 fatty acids due to lipid peroxidation. So anyways, you're going to be exposed to some of these things no matter what you do. So you don't want to add to it, okay? You don't want to add to it by eating in a foolish way or exposing yourself to toxins unnecessarily. So here is glycine. It's the smallest amino acid. And here is glyphosate. They're very similar. It's basically, think of it as glycine plus a phosphate. There's a little bit more to it than that, but that's all you really need to know. So here's an amino acid. An amino acid has a central carbon called the alpha carbon. It's called amino because it has an amino group on it. It's called an acid because it has an acid group on it, carboxylic acid. And then it always has a hydrogen on it. And then the alpha carbon also has one variable component, and that is the R group. And the R group in glycine is only a hydrogen. So it is the smallest amino acid. And being small with only this hydrogen here, that makes it a perfect amino acid to put into an enzyme active site to create space, a pocket, so to speak, where the substrate can bind the enzyme. All right. This tiny little side chain also works great if you're going to twist a molecule into a helix, like collagen, the most common protein in the body. About 1/3 of our bodily protein is collagen. And to twist it into a helix, it has glycine every third residue. That's going to be super important. The reason it's so important is because glyphosate can substitute in for glycine. Okay. And here it is, Stephanie Seneff. Glyphosate substitution for glycine can explain many diseases associated with glyphosate. All right. So here you see that you got an alpha carbon here, and then there's also a nitrogen here. But for our point, the big thing is this big honking phosphate sitting here. So this will sneak into a protein. It'll substitute itself in for where glycine should go in our bodily proteins. And that it's often present in enzyme active sites, and it'll cause those enzymes to become dysfunctional. Also, this tiny little side chain works well for ion channels. You can create a big hole in the center of a helical protein, and you can let an ion float through there. Well, if you put this bulky phosphate in there, you've now not only plugged up the center of that ion channel protein, you've also put a charge on it, because this is going to be charged at physiologic pH. And that's going to make it repel a lot of ions. So it messes up the function of enzymes. It messes up the function of ion channels. That's going to end up being a big deal. Okay, here's how an enzyme works, by the way. Here's the enzyme. Here's the substrate. So substrate number 1 and substrate number 2. These are the things that react together to make a new product. There's going to be a transition state in the reaction before they combine, and that's the transition state, and then they separate, and those are the products of a reaction. This is basically how you can explain virtually all chemical reactions. Okay, so the enzyme has to have a shape that will fit the substrates and hold them together so that they can make a transition state, and then they can break apart into the products. So originally, enzyme was called as being like a lock and a key, the way it fits with the substrates. And then it's also better, I think, metaphor is to call it like a hand in a glove. So if you put these substrates into this enzyme number 1, they fit into the pocket, but it doesn't orientate them correctly. So this enzyme is not working here, okay? This enzyme number 2, it holds them together nice and tightly together, and it orientates them correctly so that they can connect to each other, substrate 1 and substrate 2, substrate 1, substrate 2. So this will cause a reaction to occur. An enzyme can also be like a magnet. Here, for example, we have a carboxylic acid, which is deprotonated, and it has a negative charge on it. The key point is the negative charge will attract a positively charged substrate to come in and bind to it. The substrate is sometimes called the ligand, but we'll call it a substrate with a positive charge on it will be attracted to the negative charge right here sitting in the active site. So here's another diagram of a chemical reaction. You start out with the substrate, and then under normal conditions without the enzyme, it would take too much energy to produce the transition state, so the reaction never occurs. But with the enzyme, the transition state will have a lower energy level, so this reaction will occur, and you'll end up with product which quite often have a lower free energy, meaning they're more stable than the original substrate. So this is a typical chemical reaction, and to make this happen, it's called catalysis too. You catalyze it with the enzyme to speed things up a lot, millionfold. All right, so again, instead of having this little side group of a hydrogen, you got this big honking phosphate sitting over here, and that's going to mess up enzyme function. Okay, when you're synthesizing a protein, this glyphosate will get substituted in for glycine, and this big honking phosphate is going to mess things up. So here's an enzyme, and let's say this is the normal enzyme, and it has a glycine in the pocket of the enzyme, the active site, and that glycine is very small, so there's lots of room for a big bulky set of substrates to come in here. But now if you substitute glyphosate into that protein that makes up the enzyme, and it's phosphates projecting in the enzyme active site, you've double messed up this active site. This active site is messed up and will be dysfunctional because there's a negative charge on the phosphate, which is quite often going to repel things. Plus, this phosphate is a big bulky thing, and it's going to block the substrates from fitting into the pocket. You know, like it'd be like, it's just a big giant thing. It'll be like trying to hold a baseball in your hand while you're putting your hand into a glove. It's not going to work. So the enzyme will become dysfunctional. Okay. And you can even predict where is glyphosate substitution likely to occur. It's likely to occur where there's actually two glycines next to each other, or something else very small, like perhaps an alanine, which only has a methyl group on it, because that creates more room for the phosphate to get stuck into the protein. Okay. It'll often occur when there's also a positively charged adjacent amino acid, something like HAL. HAL stands for HAL, histidine, arginine, lysine. They're all positively charged amino acids. So this allows the bulkier glyphosate to substitute into a protein, and you can kind of predict which proteins are likely to be affected by this. So Stephanie Seneff has written a bunch of paper proposing this as the main mechanism. There's a whole bunch of other researchers too who have studied this stuff, but she's the most famous one. Okay, and it's like a Trojan horse. Once the glyphosate gets in there, it seems harmless at first, but it messes up the function of many enzymes and other proteins by doing this. Okay, nice Trojan horse painting. Okay, so this, according to Stephanie Seneff, is just some of the ways that glyphosate is harmful to the body. And trust me, I didn't have enough time to go through all of them. There's a bunch more, all right? It's interfering with your cytochrome P450 enzymes, and that's a big deal. They're relevant for a whole bunch of stuff. I'm not going to bore you with reading off this list, but just trust me, I wouldn't need anything with glyphosate in. I think it's a highly toxic substance, and I think that she had convincing arguments in her papers and her book and the other papers I read written by other authors. I would avoid this stuff as much as I could. So then you want to know, where is it going to be located? It's going to be sprayed, especially on GMO soy, but it's also sometimes sprayed on GMO corn. And there's other crops that get sprayed on that are not even GMO stuff. We'll talk about that in just a moment. These are a bunch of diseases that she says are associated with it. Autism is how this all got started. She was very concerned about some children who had autism and trying to study it to understand autism. And in her process of trying to understand what causes autism, she then came across all these papers on glyphosate. That's how this all got started for her. And she sort of dedicated her life to studying glyphosate. She's written a bunch of papers about it. She's given tons of lectures, tons of online video lectures of her speaking about glyphosate. And it is associated with increased risk of lots of the common modern diseases. You know, how important it is for causation, that is in many cases debatable, but there are certain good reasons to be very concerned about it. This one French researcher, Gilles-Eric Seralini, fed rats glyphosate. And what he did that was unique was he kept them on it more than 3 months, for a long time. And he showed a marked increase in breast tumors, for example. He was forced to retract the paper despite no fraud or intentional distortion of results, but it was republished in another journal. And he also showed a lot of the additives given with GP, like the newer, more powerful versions of it, they're also toxic in his opinion. IARC, this international, I think it's agency or association for research on cancer, they declared it a probable carcinogen. That's on TL. When you see this abbreviation, that means Toxic Legacy, page 20 of Seneff's book. It's also associated with a lot of other problems. So couple things. Now we're going to start talking about blood flow. This is going to relate to glyphosate and non-organic food. And I think this stuff is really fascinating. And this is stuff that if you're interested in atherosclerosis, the most common reason people die, plus atherosclerosis increases the risk of cancer, it increases the risk of dementia. This is good to know. A red blood cell has a negative charge on its outer surface. That's because its plasma membrane on its surface has things like sialic acids, which are negatively charged. A sialic acid is like a glucose with a carboxylic acid on it. It also has cholesterol sulfate, and it also has endothelial glycocalyx with the sulfates on it. Okay, I'm going to show you pictures of that in just a moment. But what you need to know is the negative charge on the outer surface of a red blood cell, they're called erythrocytes, is called the zeta potential. You have to know that. That's fundamental to understanding anything about an artery. Okay, And by the way, that's not taught in medical school. I've never met a medical student or a doctor in my entire life that's ever heard of zeta potential. And it's like one of the most basic, useful, important things you could ever know about atherosclerosis. Okay, so the zeta potential of one RBC and another RBC, they're both negatively charged, so it prevents them from sticking together. It prevents clotting. You want to prevent clotting. Clotting is why people die, okay? Hardly anybody dies from bleeding. Yeah, it does happen, but it's a rare thing, okay? People die from clotting all day long every day. They clot an artery in the heart, that's a heart attack. They clot an artery in the brain, that's a stroke. Now, there's things that can stick these red blood cells together. Here's an IgM antibody, like the acute phase of an infection. It's big, it's bulky, it's positive charge. It'll hold the RBCs together and get them to clot. IgG, these are the smaller ones. You'll see those with multiple myeloma, but unless you got tons of multiple myeloma, they usually they're not big enough to hold the RBCs together. So here's an artery, and here's the inner lining. This is the glycocalyx, the sugar coat. Here is the intima, and this is also called the endothelium. The single layer of cells is called the endothelial cells. Endo means inside. Thelial is just like part of the lining of something, all right? And then you'll have the media, the adventitia out here. All right, for our purposes, what we care about is this glycocalyx, the inner lining of an artery. And you can see it right here. They've got it color-coded in purple, and this will have a negative charge on it. We'll explain the reason for the negative charge. So the glycocalyx also has a zeta potential, and that prevents the red blood cells from sticking to it. You don't want them to stick and clot. Couple things to notice. Look at how a white blood cell is about twice as big as a red blood cell. Red blood cell is about 7 microns in diameter, and a white blood cell, let's say neutrophils, it's about double that, 14 microns in diameter. That's going to be useful to remember. A capillary is usually only about 5 microns in diameter. So even under normal conditions, RBC has to deform a little bit. A WBC has to deform a lot to fit through a capillary. WBCs also have a zeta potential, a negative charge on their outer surface. So here's a glycocalyx, and the glycocalyx usually projects up high. You could think of this as being like trees on a hillside, okay? I've also heard a nice expression. There's a lady by the name of Vivian Lowe, MD. She had a clever metaphor. She says it reminds her of like moss on a stone at the bottom of a stream. Okay, that's a good idea. It's very slippery and lubricated, and because it's like a gel. I'm going to explain all this in a moment, but just remember that it's lubricated and really slippery. So the red blood cells, white blood cells slide right by. By the way, in the blood, there's about 700 red blood cells for every white blood cell. So it's like more than 99% of the cells are red blood cells. So that's important to know too. So they're a rarity, white blood cells compared to red blood cells. Okay, now these things sticking up high in the glycocalyx, they're going to be heavily negatively charged with something called heparin sulfate. The adhesion molecules for clotting, they're all down low. So as the glycocalyx is intact, the adhesion molecules which promote clotting or promote metastatic cancer spread, they're down low. So that's why you want to keep the glycocalyx intact so you don't get clots and you don't get metastases. Okay, once the glycocalyx is destroyed, the white blood cells can bind to attachment receptors down here, adhesion receptors, and they then can enter the subendothelial space. The blue cells are the endothelium, so to pass below that is to enter the subendothelial space. So we're going to talk about things that can make this happen. All right, so now this is also, I think this is very beautiful actually. Here's a red blood cell with a negative charge on its surface, and it's kept from sticking to the endothelial lining by the negative charge. They actually wrote positives here, but that's a confusion. This positivity right here is just for the ions in the blood itself. There's actually a negative charge all along the surface of the endothelial glycocalyx. Here's a heparin sulfate. The sulfur is the yellow, and the reds are the oxygens around. It's going to be associated with 4 oxygens. It's going to have a -2 charge for each sulfate group. Okay, but the point I'm saying is this is also brilliant. This is why, another reason why I believe in God. This is so complicated to learn how this all fits together. It's like a miracle. It's so cool and interesting and beautiful. Okay, so anyways, a red blood cell does not stick because the glycocalyx has a negative charge along it, all right? And these are all the endothelial cells right here. We're going to go through this anatomy in more detail. We're going to go into how endothelial glycocalyx is built. Also, you're going to see this word quite often, exclusion zone of structured water. And structured water is another name for the 4th phase of water, meaning that this is all a gel. This is like jello lining the inner part of a red blood cell. And it's highly lubricated. And it's also, you know, Vivian Lowe described it as being a bumper car. The red blood cell comes up close and it bounces off of it because they repel each other by their negative charges. So everything, when things are working well, it's beautifully designed and it works. Okay, so here's a bunch of red blood cells traveling through the blood. Here's a white blood cell. This, by the way, is a lymphocyte. This would be like more like a neutrophil. It's sometimes called a polymorphonuclear leukocyte because it'll actually have a bunch of lobes to its nucleus. The lymphocyte has a nucleus that's about the size of a red blood cell. That's a good internal control. If you're looking at a peripheral smear of blood, You look at that lymphocyte nucleus to see, and it should be the same size as a red blood cell. That tells you you're dealing with normal size cells. All right, you want to know that you're not dealing with megaloblastic big red cells from a vitamin B12 deficiency. You're not dealing with small red blood cells, microcytes from iron deficiency, for example. Okay, iron deficiency is more common in teenage girls because they simultaneously hit puberty and start menstruating, and that's when they need more iron when you're in that growth phase. Most women who are premenopausal, they're lower in iron, but they're no longer growing so rapidly after they get in their 20s, for example. Okay, men tend to be iron overload after 20. I just gave a lecture recently on Chef AJ, so I'm going to all that stuff. But anyways, you see all these red blood cells floating together. How come they don't stick together and clot? The reason is they all have zeta potential, so they repel each other. So it's rather beautiful how that is all designed. Zeta potentials enable all the red cells to travel without sticking together. Okay, so here's another view of it from the side. Here's the red blood cells. They normally deform a little when they go through a capillary, again, because they're a little bit bigger than a capillary. They're about 7 microns in diameter. Capillaries typically about 5 microns in diameter. And here's the endothelial cells right here, and they're relatively flat. And here is the endothelial glycocalyx. So this is slippery, and the red blood cells travel through. These are things that make it slippery. You'll have these proteins, proteo for protein, glycan for sugar. So it's a protein with sugars attached. The most common sugar is going to be something called heparan sulfate. I'll show you a picture in just a moment. But this is all good, that it's slippery and the red blood cells go right through it. Basically, the endothelial glycocalyx lubricates the capillary, and it has a whole bunch of molecules that interact with the blood. It has extracellular superoxide dismutase, which neutralizes any oxidative stress. So when you have endothelial glycocalyx intact, you have some protection against oxidative stress, let's say from eating some oils or from excessive free iron. It is your friend. Hyaluronic acid, I like it drawn transversely because it helps to cross-link the glycocalyx. You're going to see that come up as well. Okay, glycoproteins tend to be shorter in height, and they tend to be your adhesion molecule. So glyco means sugar, this means protein. These are mostly protein versus a proteoglycan is actually mostly sugar because it's got tons of sugars attached to it. And I'll show you better pictures of that in a moment. Okay, here's the structure of heparan sulfate. So this is what you have all over the place. This is the most common sugar, and usually they'll use the word glycosaminoglycan. That just means repeating units of disaccharide. So saccharide is a sugar, disaccharide means 2 sugar, and you'll have these repeating disaccharide units. And these things are there's tons of them. All right, but the point that I want to get out of looking at this is, look at the sulfate here with the negative charge. Okay, look at the sulfate with the negative charge. And then here's the sulfate attached to an amino sugar. And there's also some carboxylic, COO minus is a deprotonated carboxylic acid. So tons and tons of negative charge, negative charge, negative charges, negative charges, negative charges, okay? So all these negative charges provide a zeta potential to the arterial lining, endothelial glycocalyx, and they repel the white blood cells and the red blood cells. That's all good. So that's what you want to get out of that it's highly negatively charged. Okay, here's normal conditions again. Highly negative charge glycocalyx repelling the blood cells traveling past. When you have a dramatic loss of the glycocalyx, it all gets cut up and shed, the glycocalyx, and it travels in the blood. That's actually bad, like in sepsis, and that'll cause brain damage. I'll explain why that causes brain damage in a moment. When you have a mild or chronic damage to the glycocalyx, like this in diabetes, it's thinned out, and you'll have a higher risk of clotting. You'll have less ability to prevent infections. Diabetics are really sick. Diabetes is a really bad disease. Okay, so this is just showing the same thing. And a reminder is that cholesterol sulfate is carried on the plasma membrane of the red blood cell. That's partly how it generates its glycocalyx. And when it travels through the capillaries, it will drop off these cholesterol sulfates, and they will then pass over to the endothelial glycocalyx and be added to it to help it generate a negative charge. Seneff even thinks that some of the oxygen on these will actually continue on and contribute to oxygenation of the tissues. I haven't studied that extensively enough to know how important that is, but it's a rather interesting statement. Okay, now here is something from the research of Gerald Pollack, and this is also really fascinating, cool stuff. So again, here's the 3 phases of water we learned in high school chemistry. There's liquid water in the body, that's also called bulk water. There's water vapor, gas phase, and there's solid phase, ice. But in the human body, actually, most of the water is in the gel form. That's almost all of it. The only exception would be your blood, which is in the liquid, bulk water phase. Also, your urine, your sweat, your saliva, your tears. Okay, so most of the water in the human body is this gel-like bulk water, including in the cytoplasm, including in the glycocalyx, including in the extracellular matrix. And nobody was really aware of that until this guy figured this out just in the last 30 years. So that's rather brilliant. There were some hints at it before, but he really figured it out. He's got a lot of good videos on YouTube if you're curious to study him. He's got a good book too, Fourth Phase of Water. I'm actually reading it right now. Human body is about 2/3 of water by mass, but 98% of the molecules in the body are water, if you count just how many molecules. And water is a universal solvent of the body, but most of it is in this gel phase. And you need adequate amounts of sulfur to maintain that gel phase. But it's not just sulfur, it's sulfate. Sulfur and sulfate are not the same thing. Sulfur is the atomic, the element, okay? But sulfate is sulfur bound to 4 oxygens. It's a different thing than sulfur by itself. What happens, sulfate is a cosmotrope, meaning that it tends to get water to form a gel. And when it forms a gel, in a sense, it's crystallizing. And during crystallization, it'll expel other molecules to some extent. And it will also lead to a clustering of negative charge in this structured water, this fourth phase of water. He calls it EZ. That's his favorite word for it, Pollock. For me, I like to call it a gel. That just helps me. All right. And by having charge separation of the negative charge of glycocalyx, you get a positive charge lined up adjacent to it that's excluded by the crystallization component of the gel. You have a separation of negative and positive charges. That becomes a little bit like a battery. It's a source of energy. You can actually get multiple layers of this structured water, easy water, due to the gel component with the sulfates. All right. And the blood passing by again is in the bulk water phase. And here's Pollock's illustration showing how it's like a battery. And then when you get inside of if you get inside of a cell, you're going to have structured water inside the cell too with negative charges. And these charge differences, they cause some energy in the cell. They actually help a cell to do work. We're not going to get into all that. That's obviously a big topic. I want to just show you what these membrane proteins, so these are called proteoglycans. This is what your glycocalyx is made out. And glycocalyx is super important. This is actually one of the most important slides in the thing. And trust me, it's not as complicated as it looks. You will be able to understand. This is actually be simple. You're going to remember this. This is actually easy to know. If you're trying to remember this and keeping notes, you might want to make a print screen of this picture here, because this is a key thing to understand. Here is the core protein of the proteoglycan. Proteo meaning protein, glycan meaning sugar. And the core protein extends from the plasma membrane of the endothelial cell up into the glycocalyx. It then has these sugars that are called GAGs, glycosaminoglycans. Glyco sugar has an amino on it, glycan it's sugar. So they're repeating disaccharides. So there's alternating sugars. We're not going to go on the subtypes because that's actually a big topic too. But the whole point is these have tons and tons of sulfates on them with negative charges. And the negative charges will attract water at their border, because water itself is polar, meaning that it has different charges on different ends of it. And these are dipoles, meaning partial charges. So it has a partial positive charge on its hydrogen, another partial positive charge on its other hydrogen, and it has a partial negative, 2- charge on its oxygen. So these dipoles, they all line up with the hydrogens aligned along the sulfates of the glycocalyx. And this combination of water with sulfate, and the sulfate being cosmotropic, meaning predisposing to form a gel, like a jello, that's how it all forms. That's how it works. And heparin sulfate, this type of glycosaminoglycan sugar, is the main ingredient in the glycocalyx. The other thing that happens is right at the tip of these GAGs, of the heparin sulfates, you're going to get a sialic acid, which is really just like a sugar with a carboxylic acid on it. For our purposes, that's all you need to know. This is going to be highly relevant, okay? This sialic acid is going to be the identity card of the cell. This is how the immune system recognizes that the cell is normal and healthy and belongs there, okay? Super important. And also, this is going to be another reason why you don't want to eat meat, especially not, like red meat, beef and dairy, because it's going to mess up glycocalyces. We'll talk about that in just a moment. It's going to mess up the sialic acid on the glycocalyces. All right, here's a sulfate. Again, it's not just a sulfur. It's a sulfur with 4 oxygens bound to it and a 2- negative charge, okay? All right, this is just a lot of detail about sulfurs and sulfur chemistry. We don't need to go into all that, but just know, where does the negative charge come from on RBCs or on your glycocalyx? It comes from the easy water gel effect. We talked about that, separation of charge. It comes from all the negative charges on the heparin sulfate, okay? Heparin sulfate is a type of glycosaminoglycan, the most common type, okay? But there's other types. There's chondroitin sulfate, which is more common in your cartilage. Right here is the word if you're curious about the word. But that's the main one, heparin sulfate by far. Cholesterol sulfate also has a negative charge on it because of the sulfates. Sialic acids have a negative charge on it because of the carboxylic acid component, okay? And these things all contribute to the negative charge of the glycocalyx and to the zeta potential of other structures like your cells, your red blood cells, your white blood cells, for example. Now, this guy right here, his name is Andre K. He has a YouTube channel where he gives biochemistry lectures. And he's actually a very good biochemistry teacher. I've learned a lot from him. But the reason I got this picture is I like the way he drew this proteoglycan. So what he's showing is the function of a proteoglycan in a joint, making up your cartilage. So let's say you're walking just down a path. When your foot hits the ground, there's impact. And the impact will compress the cartilage. When the cartilage is compressed, this is just a proteoglycan. So this would be our core protein right here. And this would be our heparin sulfates, or in this case, chondroitin sulfates. And this would be the water attached to them. So here's all the water attached to them. But when there's impact, the cartilage is compressed and the water bounces off. But as soon as the weight comes off of that foot, the water goes right back to it. So this is a way that you can simultaneously get a shock absorber and a lubricant within your joints. And it does the same thing in your arteries. You know, there's just not as much impact, of course, in your artery, but there is the impact of blood flow, blood pulsation. So I'm just saying, this is beautiful. This is brilliant. This is great. And the other thing too, think about a genius. Let's say a genius human dedicates 40, 50 years of their life to studying one little tiny part of metabolism, 100 millionth of metabolism. They win a Nobel Prize. Versus when you read about biochemistry and molecular biology, it's so beautiful and clever the way the body does all these things. It's actually, I find it an aesthetic pleasure to study this stuff. It's so cool. Okay, so here's the hyaluronic acid in cartilage is very similar to the glycocalyx. It's a little bit different. Let's just say a hyaluronic acid is the backbone in this example of cartilage here. The glycosaminoglycans, meaning the sugars attached to the core protein. Here's the core protein, same type of concept, are primarily chondroitin sulfate. And then here's the water dipoles all aligned with the hydrogen, the positive charges next to the sulfates of the chondroitin sulfates. Okay, so that's how it works. And like I said, when there's impact downward, the waters will bounce off and they'll come right back when the impact is resolved. Okay, so the relevance is if you're sulfate depleted from, eating this glyphosate or for other reasons, not getting enough sunshine, you'll have thinning of your cartilage. Okay, and then you'll have less zeta potential in your cartilage. Let's see. They compared the cartilage of OA, means osteoarthritis patients, versus patients who had fractures. And they found that OA patients had worse cartilage. All right. Cartilage is essentially very much like water, mostly. That's the most common ingredient in cartilage, and also a lot of collagen. So things that mess up collagen will mess up your cartilage. And glyphosate can disrupt collagen synthesis. We're going to go in that. F- water can disrupt it. Alcohol disrupt it. Tobacco smoke will disrupt it. Proteoglycans and chondrocytes are a less important component of cartilage. Okay, the bottle brush, these, as we saw those proteoglycans with all the negative charge on, they look like bottle brushes, the type of brush you would stick in to clean out a test tube. And so when the red blood cells go through here, I'll show you a better picture in just a moment, but they rub against these bottle brushes of the glycocalyx to some extent. It reminded me like a car going through a drive-through car wash with those big brushes going around it. And these proteins, some of these proteins come from the liver, some of them come from other locations, some of them are made by the endothelial cell, and all of this stuff has to work together, and it all does. So it's brilliant. Okay, this is just another picture reminder. Core protein in the endothelial plasma membrane, core protein then attached to tons of these sugar residues, repeating disaccharides of heparin sulfate being by far the most common one, heavy negative charge attached to the water dipoles, creating gelled water, easy water, structured water. Okay, here's a plasma membrane just showing the difference between, here's a regular cholesterol. It only has a hydroxyl group on it, so a very weak polarity. And they actually stiffen plasma membranes, okay, versus a cholesterol sulfate has a lot more negative charge on it. And the red blood cell plasma membrane carries these around and then will donate them to the endothelial glycocalyx. This is the difference between human plasma membranes versus plant plasma membranes. A human plasma membrane is stiffened by cholesterol. In comparison, a plant plasma membrane has fiber, what we call fiber, on its outer surface to stiffen it. So that's why animal foods, they always have cholesterol. And that's why plant foods always have fiber, because the plant foods don't have cholesterol, okay? Here's a cholesterol molecule, and you can see it's very hydrophobic, meaning it doesn't like water. Hydro, water, phobic, mean hating, okay? So all it had, the only minimally polar thing it has on, it's got a little hydroxyl group, meaning an OH. All right, you stick a sulfate on there, now you got this big bulky thing with a double -2 charge on it. You got -1 free, but this is much, much more polar. So It's a lot easier to transport cholesterol through an aqueous solvent when you got it sulfated. Also, remember, sulfate is cosmotropic, meaning that it causes water to gel. So you don't want sulfate traveling around in your blood free, because you don't want your blood to become like jello, to clot. That would be bad. So they're mutually beneficial, the sulfate to the cholesterol molecule, and the sulfate also combines with all your steroid hormones to transport them in the blood. So this sulfate plays a very important role. Not many people know about it, facilitating the transport of steroid hormones in the blood and the cholesterol sulfate. And so it's a way to get these negative charges transported around so you can stick them into your glycocalyx where you need them. By the way, this is a good word to know. Hydrophobic means something that is not water soluble. Cholesterol by itself is not water soluble. But amphi, like an amphibian, can live on land and water. Philic means that it can be soluble in either an aqueous phase or an oily phase, and that can be very valuable for a molecule. We'll get into that some other time, but you're going to want to know that word, amphiphilic. That's very useful in understanding physiology. Okay, here's just another picture of it. Endothelial glycocalyx is typically about 0.5 to 5 microns thick. It's thicker in certain locations than other. Again, glyco means sugar, calyx means coating. Here's a nice healthy glycocalyx with the negative charges all up high and these adherence molecules down low. If you damage the glycocalyx, it's cut off. All the adherence molecules, adhesion molecules, you might call them, are down low, and they cause all the trouble. They stick to white blood cells and let the white blood cells get subendothelia. You don't want that. Okay, here's just another picture of it. It just shows you the plasma membrane of an endothelial cell, quite nice. It's sort of like every picture I saw in these different journal articles, each one would show one feature of it nice and maybe screw up the other features, but the main point is made. The healthy stuff sticks up high, the adhesion molecules are down low, and when you lose the healthy stuff, the adhesion molecules are exposed that cause clotting and inflammation and allow these like neutrophils. Here's a neutrophil, polymorphonuclear leukocyte, to get through the membrane and get down subendothelial. So subendothelial means below the endothelial cell, the lining cell of the artery. Oh, here's the shear stress of the blood flow, and that's going to displace the glycocalyx and cause it to release nitric oxide. Okay. Here's when you have diseases. If you have free radicals, reactive oxygens from eating omega-6 fats or from excess free iron, they're going to damage this glycocalyx, and they're going to activate this whole inflammatory process. Pro-inflammatory cytokines from an infection, for example, they're going to cause a lot of problems in here. Eating a high-fat meal is going to activate the neutrophils to release myeloperoxidase. We'll talk about that in a moment. That's going to damage the glycocalyx. Disturbed flow, abnormal amounts of turbulent flow or retrograde flow due to hypertension at bifurcation points, that's going to damage the glycocalyx. If you have large-scale damage of the glycocalyx, for example, due to a severe infection like sepsis, the heparin chains will be released, and the body will actually have a hard time processing them. It'll try to remove them from the body, but they become what is called the DAMPs, which means damage-associated molecular patterns. If you have an infection, that's a PAMPs, pathogen-associated molecular pattern, but that word does come up much. And we're going to talk about the effect of the glycocalyx when it's damaged in sepsis, and we'll get to that in a later slide, but that's going to be relevant. Okay, here's kind of a neat picture. They're showing a red blood cell traveling in this direction through a capillary. All right, so normally the red blood cell will be folded back on itself, but just for the sake of the picture, they drew it sideways. And this is where I get the metaphor of a car in a drive-through car wash. So the car drives through the car wash, and the red blood cell is the car, and all the glycocalyx touching it is like the brushes in the car wash. All right. Here's showing a cool picture where they caught on an electron micrograph the red cell traveling through the glycocalyx. Here's a spot where there's no cell, and the glycocalyx puffs into almost the middle of the capillary. Here's a big honking white blood cell, and you can see when it passes through, it's smushing the glycocalyx down up against the cell. And the glycocalyx has that bounceability, just like we talked about the cartilage in the joint. So it's absorbing the impact, if you will, of this monstrous leukocyte. Leukocyte just means white blood cell passing through, and then it'll bounce back into form once it's passed. Okay, so it's lubricating the things, plus it has that almost elastic-like ability to bounce back into shape. These are some of the things that the endothelial glycocalyx does. When the proteoglycans are displaced by the shear stress, which means the blood flow, it pushes them over a little bit, and that activates eNOS. eNOS is endothelial nitric oxide to make nitric oxide. That's a vasodilator. Just like Viagra increases nitric oxide in the Johnson, in the arteries, nitric oxide is released to vasodilate, to open up the artery. It also helps prevent clotting. And if you hear Dr. Esselstyn talk about preventing atherosclerosis, he's going to talk to you about nitric oxide all day long. I went to his course and visited him out in Cleveland. And he kept going on and on about endothelial nitric oxide. And, I was sort of like the annoying person in the audience. I said, well, what about this? What about this? What about this? And he goes, we'll talk about that later. And then he came over to me at lunch and he goes, Pete, I need to get the audience to understand nitric oxide. If they not understand nitric oxide, they're going to have a great result. All this other stuff, you're just going to confuse them. If they understand nitric oxide, they'll get great results. So he says that's why he focuses on nitric oxide. And nitric oxide is the most important thing. It definitely is the most important thing. There's just a lot of other stuff going on too that's rather interesting. All right. Maintains the tight junctions. It regulates the permeability of what's going to get through that endothelial layer. It interacts with the immune system. It interacts with other cells. Okay, now here's when there's problems. We talked about hypertension causing abnormal amounts of turbulent flow, retrograde eddy flows, and that's going to lead to shedding of the glycocalyx. They show a scissor here for the glycocalyx being clipped off and shed into the blood locally at bifurcation points. When there's infections, it'll be more widespread. Your neutrophils can release part of like their nuclear inner contents, and they're called nets, and they are like a trap for inflammatory infections, and they cause a big mess. There's a lot of reactive oxygen species generated from that. All of this stuff is bad for the glycocalyx and can cause it to be shed, okay? When you shed the glycocalyx, complement can be activated, part of the immune system, causing these big immune responses. Clots can form along the endothelium. All of that is bad. Atherosclerotic plaques can form along the endothelium. All of this stuff is bad, okay? So we talked about sulfur being a major transporter. Sulfur, here it is, transporting cholesterol sulfate, making it polar enough to be transported in the blood. Usually this will be part of the red blood cell plasma membrane. It's also going to bind with all these hormones. These are all your sex steroids, estrogen, progesterone, testosterone. So the point I'm saying is glyphosate can cause sulfate deficiencies, and so that can interfere with your ability to transport all these steroid hormones around. That's not good. It also has an effect on neurotransmitter metabolism, which is a little bit of a separate subject, but it's relevant, okay? And you can see here it is transporting a serotonin. Let's see, barrier function. These are just things that endothelial glycocalyx does. It has a barrier function to decide what gets under that endothelium or not. If the proteoglycans are shed, these are all a bunch of different things that can cause it degraded. Then you damage your endothelial barrier, you're more prone to clotting and having inflammation. Sulfated glycosaminoglycans become depleted in sulfate when they're chronically exposed to glyphosate or glyphosate. So, and this is the lady again, Stephanie. She wrote a whole bunch of papers on it. Not good. This talks about sunshine helps you to make it. So it's good to get sun. It just feels good, and it feels good for a reason. You don't want to overdo it, but it feels good for a reason. I don't use sunscreen, by the way. I've got separate lectures on that, but I actually could have maybe lectured on sunscreen, but I don't use sunscreen. All right, because I think you're better off just getting sun. I just don't stay out so long. And if I need to stay out longer, I'll wear a sombrero or something. All right, it's very anticoagulant in the tops of the glycocalyx, but if you shed the top, then the lower parts are actually prothrombotic. We'll talk about that later. It interacts with a bunch of molecules. For our purposes, we already talked about superoxide dismutase, and also antithrombin 3 is an important part of it. Mechanotransducer to generate nitric oxide. Yeah, we talked about that. Prevention of angiogenesis. Okay, this is a cool picture. This is showing that as the red blood cells travel through the capillary, they're releasing cholesterol sulfates, negative charges, to the endothelial glycocalyx lining of the arterial wall, the capillary wall. What's also interesting too is that the venous end, because of the respiration with the CO2, carbon dioxide being expelled into the vein, it's going to have a little bit of a acidic positive charge, and that also facilitates attraction of the red blood cells, helps to push them through the capillary. And it's all part of a mechanism that enables the big red blood cells to travel through the small capillary, and in a way that doesn't require additional energy from the heart. So it's a very clever mechanism. And there's an additional mechanism that's a little more complicated. I won't go into it, but what I'm trying to say is it's beautifully designed to make everything work with minimum pressure required from the heart. Okay, this is just more of the same type of picture. Normal blood flow, the red cells are all separate, but if you have a bridging molecule, something that sticks the red blood cells together, which can be LDL cholesterol, can be an IgM antibody, it could be uric acid from high uric acid levels from eating too much meat, too much fructose. This could be fibrinogen, the clotting protein released during inflammation, could be fibrinogen released due to stress. High psychological stress will cause increased release of acute phase reactants, including fibrinogen, clotting protein made in the liver. When that happens, you start getting the red blood cells all sticking together. and a high-fat meal will do it. You know, the LDL cholesterol, even just the chylomicrons in the early phase of fat absorption will cause these red cells to stick together. When the red blood cells are stuck together, it's harder to push them through the capillary. Blood pressure has to go up. So that's not good. Okay. Normally, when blood flows through a blood vessel, it's going to be what's called laminar flow. I'm looking at my clock here. How am I doing for time? All right. And so you're going to have the red cells in the middle.
You're fine, Dr. Rogers. Don't worry.
Okay, thanks. You got red blood cells in the middle. You got white blood cells next to it. And then you got the plasma on the bottom of it. So you can make your thumb is like what blood flow is like. And that's normal blood flow, laminar velocity profile. Okay. And when these endothelial cells are exposed to laminar flow, they're very happy. They crank out lots of nitric oxide. Everything is great. But when this becomes turbulent or becomes retrograde flow is also called eddy currents, then you have problems with your endothelium. Okay, where the problems occur is at bifurcation, because the laminar flow comes up and it hits the bifurcation. Normally, under normal blood pressure, it's kind of a gentle hit on this bifurcation point. So you don't get a whole lot of retrograde, you don't get a whole lot of turbulence, and this endothelial lining remains intact. But if a person's hypertensive, then there's going to be a higher velocity of the blood flow, and it's going to hit this median divider at a higher speed, and it's going to bounce off. There's going to be more turbulent flow, and there's going to be more retrograde eddy currents, and that's going to confuse these endothelial cells because it's going to cause strange displacements of their glycocalyx, which is going to lead to a shutdown of nitric oxide production and a gradual shedding of the glycocalyx, which is going to predispose to atherosclerosis at these locations. And within organ systems, that can predispose to metastatic cancer because there is not an intact glycocalyx at those spots to prevent cancer cell traveling through the blood from adhering to that spot and then moving subendothelial. So good arterial health also helps prevent metastatic cancer. Okay, here's just a drawing showing it, for example, in the carotid artery. In the carotid artery, the flow is coming up. It's going to hit the bifurcation point. Here's the external carotid, which goes to the face. Internal carotid artery goes to the brain. When it bounces off the median divider, you get your turbulent flow here, your retrograde eddy currents, and this is where you get atherosclerosis. The atherosclerosis, it always occurs here. I look at these CT angiograms all the time, just about every day, and this is where it is, okay? Once in a while, you get an atypical, really tortuous common carotid, which will change the flow patterns a little bit. Or you'll get some normal variant, retropharyngeal carotid where the anatomy is distorted. But for our intents and purposes, this is just basically where it always occurs. And atherosclerosis, by the way, it's a blood clot, okay? Everybody knows cholesterol, and cholesterol is the main risk factor. But what atherosclerosis actually is, it's a blood clot that then chronically organizes, okay? And that's been shown by the pathologist, and that also matches my experience of studying it for many years. All right. And you kind of need to know that. I realize that's not in your medical textbooks, but if you start actually reading the research papers on it, you'll see that is the case. You'll also see that the comprehensive theory of atherosclerosis is the atherothrombosis theory of Gregory Sloop et al. Okay. And William Roberts has now gone down that path as well, the other great atherosclerotic pathologist. All right. So clots on the far wall. Okay. That's where it happens. And then endothelial precursor cells come and cover it up, and that's how it becomes subendothelial. All right, here's a picture showing an endothelial cell, and it has lots of properties. Here's all these different antithrombotic properties. And these are all the high glycocalyx, so to speak, in general. And then once you shed the upper glycocalyx and you're stuck with these, glycoproteins, these are primarily prothrombotic. And this is the kind of stuff I was joking when I was with Dr. Esselstyn. I'd be like, well, what about this? What about this? And he's like, we'll get to that later. We'll get to that later. Nitric oxide is really the only thing that matters. If you just know nitric oxide, that's good enough. Everything will make sense. Nitric oxide is released by the endothelial cells, and it prevents clotting of the platelets within the blood flow. Nitric oxide also diffuses over to the smooth muscle cells on the wall of the artery, and it causes them to relax. So you get vasodilation, and it enables more blood flow to go through the artery. That's what you want. Okay, this is showing, again, some of the effects of a high-fat meal. So I just want to show a little bit of this stuff because you get a synergistic effect. It's bad enough to eat a high-fat meal if everything's organic, but if you eat a high-fat meal and you're chronically eating glycophosphate, you're chronically eating sodium, you're really messing up your arteries. So here is healthy arteries. Here they are at baseline during fasting. And then if you do this would be flow-mediated dilation test with a tourniquet, but it could also be exercise. The artery can dilate a lot, all right? Here it is after a high-fat meal. You have less ability of that artery to dilate. This is the maximum flow, diameter you can generate. Here it is after eating a high-fat meal. But in a person who's got more baseline chronic arterial wall thickening from cardiovascular risk factors, let's say hypertension and diabetes, they've got less ability to vasodilate. So they can, they can really put themselves into a bad situation if they eat a high fat meal and then simultaneously they try to exercise and they're out in the cold weather, shoveling snow or something. They just don't have the arterial blood flow to provide adequate blood delivery to that heart. So that can cause a myocardial infarction. And then they can make it worse. Caffeine will be increasing the metabolic rate and also causing some vasoconstriction. So all these things can add up, and those things predispose to a heart attack. This image got distorted because I made it on a different computer, but the point is, in an atherosclerotic plaque, it's partially reversible because you can reabsorb the lipid core, you can reabsorb the necrotic core, you can reabsorb the red blood cells in it, some of the cellular fibrous tissue. This can all be reabsorbed. You can't reabsorb the acellular fibrous tissue, the scarring, the collagen tissue, fibrosis. You can't reabsorb the calcifications. You also, though, will get the nitric oxide to start being produced again once you remove the things like the sodium and the high fat, and that will help to dilate the artery and get good flow. So you'll often get dramatic improvement within just a couple of days from this, and this will start becoming more manifest after about a week or so. All right, peak lipemia is the spot where people get cardiac chest pain. This guy, Peter Quo, way back in the 1950s, and later his work was repeated by Ray Rosenman and Meyer Friedman in the 1960s. Basically, what they did is they fed a person a high-fat meal. They checked their blood lipids every 30 minutes. And he took a whole bunch, he was a cardiologist, took a whole bunch of patients with cardiac angina. And when he fed them saturated fat, which peaked at about 5 hours, they got chest pain, many of them. That was very characteristic. And when he fed them unsaturated fat, because there was a move in the 1960s, Ansel Keys had shown in the 1950s, that sat fat was a cardiac risk factor for atherosclerosis. So there was a big idea, well, we'll switch to unsaturated fat, all these oils, primarily omega-6 fats. And when they did that, what they found was it was even worse than the sat fat. It caused a more prolonged sludging of the blood, thickening of the blood, leading to more prolonged angina episodes. And his research workers got pissed off because they would start at, let's say, 8, 9 in the morning, and this stuff was still plugging up the arteries late into the evening. So it's bad. You really want to avoid cooking oils. That's why Dr. Esselstyn says not one drop of the oils. None of them are okay. Not olive oil, not canola oil. They're all bad. You want to avoid them. I recommend zero intake of oils. I won't eat any food that has oils in them. This paper here is some of the papers by Roy Swank. So Roy Swank is a great neurologist who found that by minimizing dietary fat, especially sat fat, he got incredibly improved results in his MS patients. And they looked at things like the arteries in the cheek pouch of a hamster. You can also look at that in a human. You can look under the tongue, sublingual. You can look in the eyes. That's what Meyer Friedman and Ray Rosenman did. And you can look at it with a microscope in real time. And what they saw is after a high-fat meal, you get clumping of the red blood cells. Rouleau means stack of coins in French. And when you got clumped up RBCs, they're not as good at delivering oxygen. So you get a relative hypoxia of the tissues. Swank found in a hamster brain, he would get like a 30% drop in oxygen delivery when the RBCs were clumped up after a fat meal. Here's one of the papers by Swank. Oxygen availability in brain tissues after lipid meals, okay? Other papers will show by like Quo, for example, 15 to 20% drop in oxygen delivery to the tissues. Things that will increase risk of myocardial infarction, sudden severe stress, and if you eat a high-fat meal, but other things that'll do it. So some people get stressed out when they're watching a sports game and they're drinking beer, they're eating salty, high-fat pizza. All of those things can add up to multiple factors increasing one's risk of heart attack, myocardial infarction. Oh, another point I want to make is here's the arteries of the heart. Here's the aorta, thoracic aorta. Here's where the arteries come off. Let's say the left main coronary artery. That's the one they call the widowmaker, because if that's blocked off, you block off all the blood flow to most of the blood flow to the left side of the heart, the circumflex artery and the left anterior ascending artery. But the point I'm trying to make here is when a cardiologist do a cardiac cath, a coronary artery angiogram, they look at these big arteries. These are located on the outer surface of the heart. They're called the epicardial arteries. And that's important. But what I'm trying to say is there's also these arteries that go into the muscle of the heart muscle. They're called the intramuscular artery, and they got small little branches and little microvasculature. And the point is they can't really even see these arteries too well. And you can only put a stent or do a bypass to these big honking epicardial arteries. But most of the arterial volume of any part of the body is in these little tiny arteries in these capillaries. And so you don't even remotely come close to treating them with stents or with bypass surgery. Okay. And atherosclerotic disease, like from the William Roberts paper, it's always diffuse. This idea of single vessel disease or just an isolated stenosis, that's not reality when you look at these arteries at autopsy under pathology. There's always a diffuse, relatively similar amount of disease everywhere. So the optimal way to fix that is optimize the diet. That's why Esselstyn got such great results with his low-fat vegan diet. Okay, so this is something called coronary syndrome X. And what coronary syndrome X means is that the person will have open coronaries when you do a cardiac cath, but they're still having all these cardiac problems. And that can be just because the arteries, the small arteries, have atherosclerotic disease, glycocalyx disease in them. Okay. So again, when you look at the big arteries in the coronaries, you can see atherosclerotic narrowing. People can have vasospasm, Prinzmetal's angina. Okay, they can get a coronary artery dissection. All right, but what am I trying to say? Tons of the arterial cross-sectional area. It's in all these smaller intramuscular arteries and in these capillaries. All right, and that could be the action zone. The vast majority of arterial cross-section in the human body, by far, I think it's well into the 90s of the percentile. It's these tiny little arterioles and capillaries. Okay. Dietary treatment reaches all of them. It helps fix versus a stent's only going to be in the big honking epicardial artery. And a lot of times that's not enough. Okay, it'll save your life during an acute myocardial infarction. Okay, but most of the time people have chronic progressive occlusion. All right, so anyways, this was just one thing about a mechanism. When the red blood cell is traveling through the capillary and it gives off oxygen, giving off that oxygen changes the shape of the hemoglobin, and on a large scale, that will distort the shape of the red blood cell. And the red blood cell, the design is so intelligent that it will actually release some ATP that will then interact with the endothelial, the arterial lining of the capillary, and it'll cause vasodilation that'll progress proximally. So what I'm trying to say is there is this brilliant mechanism whereby the red blood cells can titrate how much oxygen is being delivered to the tissue adjacent to the capillary. And it's just incredibly precise and accurate and fast, and how great it can do all of that. The design of the human body, the more you study it, the more fantastic it is, the more beautiful it is. It's aesthetically beautiful. These are all things that degrade the endothelial glycocalyx. We talked about hypertension and when it hits the median divider point. Oxidized LDL can do it. Things that cause oxidative stress will contribute to that. A high-fat diet is really bad. A high cholesterol diet is bad. High LDL cholesterol is bad. That's a bridging molecule, sticks RBCs together. High triglycerides also promote blood sludge. Glyphosate can, over time, with chronic exposure, lead to sulfate deficiency. It also makes the immune system dysfunctional, can deplete the glycocalyx, and that'll cause all kinds of other problems. Diabetes, hyperglycemia on a prolonged routine basis will damage the glycocalyx. I'm going to show examples of how damaging that is to the kidney and to the eyes. Clot formation for whatever the reason. Diabetes makes the blood more prothrombotic. Ischemia, meaning lack of blood supply to an area. I see lots of old people with a bunch of small strokes in their brains, many of them silent strokes due to ischemia, and that'll also make the blood-brain barrier more permeable at those sites. So that's bad. Excess dietary sodium, it inhibits eNOS, endothelial nitric oxide. That's why I recommend low salt. Walter Kempner had great results by lowering dietary sodium. Excessive oxidative stress, omega-6 fats, excess free iron. So I recommend avoiding all these iron-enriched foods, unless you're iron deficient, which is relatively uncommon. Most people are iron overloaded, especially postmenopausal women, but especially men after 20 years of age. Okay, because postmenopausal, she's not menstruating anymore. You know, menstruation gets iron out of the body. My whole previous lecture was all about iron and all the issues with regard to that. Excessive IV fluids. The more time goes by, the more they're finding they have to be very careful about the amount of intravenous fluids they give to patients and the type of intravenous fluids, because that potentially can cause widespread significant damage to the endothelial glycocalyx. Okay, elevated CRP, C-reactive protein, inflammatory cytokines, infections can do that. Smoking tobacco, air pollution can be harmful to the glycocalyx. Excessive alcohol, again, I recommend zero alcohol intake. Aging in general, the glycocalyx is not as robust and resilient, but people can be really healthy in their older years if they got good health habits. MPO, myeloperoxidase. So when you eat a high-fat meal, the neutrophils become activated and they release myeloperoxidase, which is going to collapse the glycocalyx. LPS is lipopolysaccharide. It's the endotoxin of gram-negative bacteria. There's also LTA, which is the endotoxin of gram-positive bacteria, which does about the same thing. Okay, and that can damage your endothelial glycocalyx. Tumor necrosis factor alpha is also quite harmful to the endothelial glycocalyx when that gets released because of inflammation. So we talked about infections, and the worst is sepsis. Sepsis will cause a sepsis-associated encephalopathy, whereby it dramatically drops sheds off, cuts off the thickness of the glycocalyx, and those particles from the glycocalyx go to the brain. I'll show a picture of that in just a moment. A few brief words on diabetes. Diabetic retinopathy in the eye, loss of the glycocalyx causes increased permeability. So you get things from the blood going into the subendothelial tissues that don't belong there, and that eventually will lead to blindness. So it's a big problem in the eye, diabetic retinopathy. Walter Kempner had a whole bunch of patients who he put them on his low-fat vegan diet, rice diet, and he took pictures of their eyes, and you would see them go from diabetic and hypertensive retinopathies to improving and having virtually almost normal appearances of the retina. So that was rather incredible. Hyperglycemia can go away. Also, here's something I thought was kind of interesting. When you hear about diabetics having proteinuria, that can be due to damage to the glycocalyx, allowing albumin, the smallest plasma protein that's real common, and that can then pass through the into the kidney and be excreted in the urine. So maintaining an intact glycocalyx helps prevent proteinuria. It helps protect kidney function. Okay. So Hans Vink, this famous researcher, has written a whole bunch of papers on endothelial glycocalyx. Albuminuria, proteinuria, is a sign that the kidney glycocalyx is damaged. Okay, some little details about endothelial glycocalyx. We're not going to go into all that stuff. Some stuff that I think you will find interesting is here's collagen. Collagen is a triple helix, meaning there's 3 protein fibrils are all wound around each other. And they got a lot of tight turns to make a triple helix. So DNA is a double helix. Collagen is a triple helix. Every third residue is a glycine, and its small side chain with just a hydrogen enables these tight turns to be made to spiral into this tightly wound. It'd be like a triple cord rope all wound together. And it's super strong. And it's actually 1/3 of the protein in the whole human body. It's the glue that holds the whole human body together. It's super important. And so glycine is a key component of that. Well, guess what? If you get glyphosate substituting into your collagen, it messes it up and it doesn't work as well. So having the glue of your body, so to speak, being damaged by glyphosate, GP, I'm going to call it GP, it's just easier to say, can really be detrimental to and accelerate your aging. And F- can be damaging to it. There's a couple other things that damage collagen. Of course, look at smoking. Smoking is really bad. You could tell a smoker, from 30 yards away, their face is all tight. They look markedly aged, older than they are. I've seen women, smoke and they really age themselves. I've seen like this pretty girl. She was smoking heavily through her teens and her 20s. By the time she was 30, she looked like she's, she looked like 30 years older than she should have looked. Okay. If you eat low-fat vegan, you could look 30 years younger than you're supposed to look. Look at all these women who look so young because they stayed vegan and they're healthy and they exercise and stuff. Let's see. So if GP makes you deficient in sulfate, it can also damage your collagen. It can damage your collagen from substituting in other things that can do it. Scurvy from like real low intake of vitamin C. You're not eating enough plants where you get your vitamin C, especially. Alcohol will do it. Caffeine contributes to it in a milder way. The advanced glycation end products from eating meat and also those produced by diabetes. There's some rare congenital disease. Those are really rare. Okay, so here's the influence of caffeine has a negative effect on collagen synthesis. Here's alcohol having a negative effect on it. Here's smoking having a big time negative effect on it. Real big time smoking. Smoking's a stupid, it's a really bad idea. Don't ever smoke tobacco. Don't ever vape. All this stuff is stupid. MJ also makes you sick. It's stupid. Stay away from all that stuff. None of it is good for you, okay? Don't let anybody tell you otherwise. They're just trying to sell you or trick you or because they're clueless. All right, now we're going to briefly talk about sialic acids. Sialic acids are the little tippy top covering of the glycocalyx. So there's a guy by the name of Roger Seaholt, MD, from MedCram. This is his YouTube channel. He's a bright guy. He describes the sialic acids on the...
It's Dr. Schwelt. He's a pulmonary doctor, and I know him. He was my doctor when I lived in the desert, just so you know, Schwelt.
Schwelt. It's a tough name.
Yeah.
But anyway, he's a bright guy, and he has a very nice lecture on sialic acids. Okay, and so they sit right on the tips of these glycocalyces, and they form like an identity card for the immune system to recognize the cell as being part of self, therefore leave it alone, or is it non-self? And the point being is humans only have this new 5-AC on there. That's like neurominic acid 5-AC, just leave it at that. So here's 5-N-acetyl neuraminic acid. Okay, but the point is 5-AC is the good stuff. It's what we're supposed to have there, as indicated by these purple ones. But if you eat meat, it's similar enough to our normal human body, new 5-AC, that it'll get incorporated into your plasma membrane glycocalyx, but it's different enough that the immune system won't recognize it. It'll see it as foreign, and it'll cause autoimmune disease. That's going to be called xenophorin sialytis, sialytis being inflammation of the sialic acids. So terminal tip sialic acids are the body's identity cards indicating self. Okay, and the immune system passes by all these things and it's sensing them. So when you get the wrong one in there, it'll cause a lot of inflammation. And that's why you don't want to eat beef and dairy. That's another thing that they do. Dairy is famous for increasing the risk of type 1 diabetes, multiple sclerosis, other autoimmune disease. And this incorporation of new 5-GC is a contribution to the mechanisms of autoimmune disease causation. Okay, so here's a picture from this research paper, xenosialitis. So from eating these types of meats that contain sialic acids of this type. Humans, by the way, can't make this. So normally this should not be in a human, new 5-GC as a type of sialic acid. But if you eat these types of meat, you will get it in your body and it'll activate your immune system and cause some inflammation. Okay, high-fat meal. I previously talked about this in some other lectures, so I won't go into too much detail about it. The most important thing for our purposes is to recognize that you're going to activate your neutrophils and they're going to release myeloperoxidase. If you're curious, you can read about this or see my previous lectures, and I go into this in great detail. So what's the point of MPO? Myeloperoxidase is a big component of neutrophils. They use it to make toxic conversion of superoxide anions into hypochlorous acid, and they use that to kill bacteria. Okay, so here it is, MPO. But when you eat a high-fat meal, they start releasing that into the blood, and then it'll interact with the glycocalyx. MPO is highly cationic. Cation is positive, so it's very positively charged, and it just binds with the glycocalyx and it destroys the glycocalyx. It causes the glycocalyx to collapse down, and the more of it's present, the more likely it'll start activating these sheddase enzymes that will just cut up the glycocalyx and release it into the blood. So the whole thing is bad. And once the glycocalyx is collapsed, then the neutrophils can bind to these adhesion receptors on the wall of the endothelial cell, and they can cause more inflammation, and they can also activate the ability to pass subendothelial. So it all just gets worse. This is one of the reasons why, you really don't want to be in the habit of eating high-fat meals, especially saturated fat is sort of the main thing associated with this, but reducing dietary fat is a diet that we're designed for. These are just more pictures of all the same sort of thing happening. Neutrophil becoming active. So here's normal healthy glycocalyx sticking up high, keeping these receptors blocked off, adhesion molecules blocked off, and then the MPO being released by the activated neutrophil because of the high-fat meal, and that trashing the glycocalyx, and then the neutrophils coming in, causing more inflammation, et cetera, et cetera. And what this is showing is you could treat it with heparin. Heparin is a medication, which is very much like the heparin sulfates on the normal glycocalyx with tons of negative charges on it to displace the MPO off the glycocalyx. Okay, but you don't want to have to treat yourself with a medication every time you eat a meal. So just don't eat the high fat would be the smart thing to do. This is just one example showing how neutrophils will interact with these adhesion molecule receptors. Normally glycocalyx negatively charged and they're repulsed because they both have a zeta potential, meaning a negative charge. But when the glycocalyx is sort of neutralized and destroyed by the MPOs, now these receptor molecules, the neutrophil can bind to them, and the tighter it's binding, it'll then form a secure attachment, and it can pass into the subendothelial space and cause trouble over there. You don't want that. High-fat meal will also distort the shape of the red blood cells. It can cause acanthocytes. I remember A for asymmetric distortion with these little spikes on them, or spurs on them, if you will. And also cause echinocytes, like an echinid, which is kind of like a porcupine. And this just means that E for echinocyte, E for equally spaced, the spurs all around the outer surface of them. So when you damage the shape of a red blood cell, you're going to decrease the amount of oxygen it can deliver. It's bad, okay? We talk about excess iron will distort the shape of red blood cells. We talked about like in the teardrop shape. We talked about how lipopolysaccharide and LTA, lipoteichoic acid, with the gram-positive bacteria, those will also distort the shape of red blood cells. They're all going to decrease the ability of the red blood cells to deliver oxygen to tissue, so they're all bad. So you don't want leaky gut. You don't want to be eating routine high-fat meals. High-fat diets also they change the metabolism of the fatty acids in the outer leaflet of the plasma membrane of the red blood cells. They'll cause more of the phosphatidylserine, it's a type of phospholipid, to flip into the outer leaflet of the red blood cell plasma membrane. And when that happens, they stiffen the red blood cell, so it's less able to deform itself as it passes through a capillary, meaning that it's less able to deliver oxygen. It'll end up having a shorter lifespan in a negative way. And that can also, it also becomes prothrombotic. We're not going to go into any more detail. Just know it's bad. That's good enough for our purposes at this point. So if you ask me the question, is organic worth it? I'll say, yeah, definitely yes. It's especially worth it to eat organic for the sake of avoiding glyphosate, for the sake of avoiding atrazine, and for the sake of avoiding GMO. If you had a non-organic food that was not GMO and it wasn't sprayed with glyphosate or atrazine, then it's not as big of a deal. I don't know. It would depend to some extent what else was sprayed on it, if anything. But like I said, I think these are under-recognized, the significance of glyphosate being a problem. What does organic mean? Well, theoretically, it should mean that there's annual on-site inspections when it's USDA certified organic. The main benefit of it, though, is to avoid GMO. They can't allow GMO in certified organic USDA. And to avoid these herbicides, glyphosate and atrazine. Also, you avoid some pesticides. I don't off the top of my head know the names of all those. What would be best? To have small local farms, the way things used to be, okay? Ideally, I had a picture in there somewhere. Maybe it'll come up on my next slide. I hope I got in here. I had a picture of that American Gothic picture. I hope I got in there. I thought it was supposed to be right there. Is all organic food okay? Of course not. There's lots of organic junk food. You can have, potato chips that are organic. Because that happened in my family. I had a lot of family members that go, hey, we're eating organic. They're eating potato chips, all this crap. Can it contain MSG? Yeah, you can have MSG in organic food. You don't want it. I think you should avoid it. I think it's worse than people recognize. How can you avoid MSG? Well, there's a lot. That's a kind of a topic for a whole other talk, because a lot of times got all these hidden names. There's something called manufactured free glutamate. Also, if you just eat single ingredient foods, they're not going to have any MSG in them. They can hide MSG, though, when it's a secondary ingredient. That's another reason why I won't eat any food that has more than one ingredient. Can organic contain GMO? No, it can't. That's one of the rules. They don't allow it. That's one of the good things about it. They don't allow atrazine. They don't allow glyphosate. What about other pesticides? It'll decrease some, but I don't have the exact names of all the other ones that are decreased, but there are real benefits to doing it. If a food is labeled non-GMO, does that mean there's no glyphosate in it? No, it doesn't. Something could be non-GMO and it could still be sprayed with glyphosate. They especially do that in cold climates, a place like Canada, for example, because it helps them to get the leaves to fall off and they can harvest it faster before the winter frost sets in. And that's done on sugarcane, soybeans, sunflower seeds, wheat, barley, rye, oats, peas, garbanzo beans, chickpeas, lentils. So that's a reason why you really want, if you're going to be eating beans, you want to be very certain that those are organic, okay? Because otherwise they can contain surprisingly high amounts of GP. So that's worth knowing. Let's see, what else? Are organic foods 100% free of glyphosate? Sometimes there can be a little, just the wind spread it over, but that should be relatively minimal. What does glyphosate do in plants? It inhibits something called the shikimate pathway, which is related to a phosphate binding enzyme, and it's used by the bacteria in your gut to produce the aromatic amino acids like phenylalanine, tyrosine, and tryptophan. It also relates to some of these neurotransmitter synthesis pathways. Okay, do companies sometimes cheat? Sometimes, usually they don't, and that's been tested by a whole bunch of urinary pesticide residue studies and herbicide studies. How much difference is the nutrients? That's a complex question. Probably not that much, but organics seem a little bit better. Okay, what can we do? Only eat plant foods. Like, let's say you go to a restaurant. Well, first of all, I'd only eat plant foods, and I would avoid corn, soy, or other foods that we know that tend to be sprayed with GP, or anything else that's known to be GMO. For what plants is it especially important to eat organic? Things like strawberries, it's real hard to wash them off. You can go to ewg.org, that's Environmental Working Group, their website, and they have a so-called dirty dozen, foods for which it's most important to get them organic. So if you're curious about that, that would be a place to go. What are disadvantages of organic? It's a little more expensive. So some people say, well, I can't afford it. Well, if you're eating starches are pretty cheap in general. So your starches, things like potatoes, sweet potatoes, rice, beans, oatmeal, quinoa, they tend to be relatively inexpensive, and they tend to have a long storage shelf life. So that's a good combination. I love the taste of fruit, but fruit's more expensive. So if you want to save money, you'll probably be eating a lot more starch, less fruit. And, McDougall will tell you it's fine to eat 90% or more of your calories of starch. The Papua New Guinea population, they were eating 93% of their calories from sweet potatoes. A person can live off just eating regular potatoes. So anyways, starch is the way to go for saving money and still being healthy. What about the environment? Yeah, organic's better for the environment. The GMO sprayed with GP and atrazine, those are largely monocrops. They'll alternate from year to year. Soybeans to provide more nitrogen to the soil as a legume, and then the subsequent year with the corn, they'll sort of eat up all the nitrogen. Then next year with the soybeans, for example. But these monocrops are more prone to, crop failures. So that's not good. You run the risk of ending up like the Irish potato famine in the 1840s, where a lot of people starved to death and a lot of people were forced to emigrate because there was no food for them. You don't want that. What foods have a GMO version? This is sort of one of the more recent lists: corn, soy, tomato, cotton, papaya, canola, sugar beets, alfalfa, also tobacco. And I'm sure there's other new ones too that I just haven't heard about yet. How safe are GMOs? I can tell you, I would never eat them. I can also tell you that guy, Jeffrey Smith, the world famous expert on the subject, he recommends avoid them. He says they're not as precise as you would guess the process of making them. He thinks they're more dangerous than people realize. He says it's like genetic roulette. He calls it chromosomal mayhem. So he would say stay away from them. Unless I was starving to death, I wouldn't eat that stuff. Anything that was GMO. Okay, is organic worth it? Again, yeah, I would do it. I think, soy is typically used to make the cheap protein for processed food. Corn is used to make the cheap sugar, like high fructose corn syrup, for processed food. I recommend avoiding them. I've talked about that quite extensively in my earlier lectures, so I'm not going to go into all that detail. I recommend only eating organic. What are the other benefits? Oh, this is kind of a joke. Other benefits: non-organic's got more pesticides and more of these herbicides. We talked about that. The corn is made into high fructose corn syrup, and the industrial process will sometimes contaminate it with mercury. This is Vivian Lowe lady was kind of funny. She said that fructose is the F word of nutrition. That was a good one. Glyphosate, we talk about all the bad things it does. Soy protein processed with hexane, not good when it's the GMO non-organic stuff quite often. I talked about, I already gave the Jeffrey Smith quotes on it. He says the best you can do is USDA organic, because it doesn't allow GMO, GP, or atrazine. Okay, a little more detail if anyone cares about some of those herbicides in non-organic food. We'll skip over that for now. I know the picture slides are a lot more fun than the word slides. I have these word slides if anybody wants to read more about them. I'll go into all the biochemistry. They're also bad for animals. Some people say, you can make your pets sick if you're feeding them this stuff. And there's some papers on that. I haven't gone to it in much detail. This is a giant thing to talk about. Senef, she's got all these different lectures. You can go on for hours and hours. Here's her book, man. This book's, what is it, about 200 pages? Look how much I marked up this book. I marked it up like crazy, and it's got all these references, and even it's all like biochemistry with no illustrations. Stephanie, if you write another book, put some illustrations in it next time, would you please? Okay. Bad for the bee colonies. If you can't afford organic, what do you do? Like I said, eat starches as much as possible, or choose non-organic foods that are not sprayed with GP or atrazine and that are not GMO. Plus, make sure you filter your water. That's an important thing. At least have a carbon filter for maintaining optimal health. They also have a negative effect on fertility. GP does, F- does, soy does. I would stay away from all those things. Now I mentioned I was going to talk briefly about sepsis in the brain. Okay, when you trash the glycocalyx, as happens during sepsis, you will cut off tons of glycocalyx in multiple locations in the body. And now this heparan sulfate will float along in the blood. It'll go to the brain, and it actually can cause brain damage. It's going to bind BDNF, brain-derived neurotrophic growth factor. Excuse me, you need neurotrophic growth factor to be forming new neurons and synapses. And for memory, LTP is long-term potentiation for memory. So sepsis, a lot of times a person will have cognitive impairment that can be relatively prolonged or even permanent after sepsis, and that's why. We talked about previous, I'm going to come back to that in just a moment. Getting leaky gut, whereby bacteria, gram-negatives and gram-positives. Gram-negatives making LPS, gram-positives making LTA. Those also will damage the glycocalyx and are prothrombotic and can lead to elevation of all these cytokines, pro-inflammatory chemicals that are going to lead to this negative cycle of damaging glycocalyx and whatnot. So here's a picture I wanted to show you. This is a cool picture. Heparin from the cleaved glycocalyx due to sepsis, some of it can get across the blood-brain barrier and get into the brain parenchyma. So this is subendothelial. Beneath the blood-brain barrier is like the endothelial layer in the brain. And the heparin combined, these are BDNFs, brain-derived neurotrophic growth factor. And once they're complex together, you can't form memories adequately because you need the BDNF to contribute to that process. So that's kind of scary. Okay, let's see. Getting into insulin resistance makes things worse. High-fat meals can cause cognitive impairment. Okay, fine. The higher your hemoglobin A1C, the stiffer your red blood cells, the less deformable they are, the less ability to deliver oxygen. Okay. The less they're able to release that ATP that I showed earlier to vasodilate the capillary and produce compensatory vasodilatation for more oxygen delivery in the setting of increased tissue activity. So you basically mess things up. It causes brain fog. It's been shown repeatedly in rodent studies. Are people getting dumber? I've talked about this before, and I do think people are getting dumber because people used to read these triple-decker 1,000-page novels back in the 1800s. And it was also because they had nothing else to do, but attention spans are decreasing. I see tons and tons of cognitive impaired patients. And I told you, I've had internal medicine friends of mine, they say virtually all of their patients over 60 are cognitively impaired. And I think it's because people tend to have multiple bad habits. And I talk to patients and I'll say, you know, sir, you might want to improve your diet. I'm like, oh, I eat healthy. I'm like, well, what's your typical dinner? Oh, lots of chicken and fish, a little bit of olive oil, you know, some red wine. I go, sir, I don't think that's a healthy diet. And he goes, no, it's just genetic. Everybody in my family has coronary heart disease. All my brothers and sisters and my parents, they all have coronary heart disease and had to go for open heart surgery. I'm like, I don't think it's genetic. I think it's because you all eat the same thing. But that knowledge has not significantly reached the public. And, you know, most of them don't buy organic. They want to save money. We talked about the dilatory theory of chronic cerebral hypoperfusion related to, for example, we tied off the carotid artery in a mouse and we get hyperperfusion in the brain. So that was a problem there. And you get the same effect by being overtreating your hypertension. All right. I've talked about this before on diabetes. We don't think we got time to go into all these things here, but what I'm trying to say is there's multiple things causing brain damage in people and impairing their cognitive function, and almost all of them are avoidable. So you want to keep your smarts, avoid all these things. All right. Insulin resistance also affects your neurons, your brain cells, your hippocampus, and causes cognitive impairment. So it's a big deal. Diabetes, you want to fix your diet to optimize it so you get better glucose metabolism in your brain. Okay, this is my theory of brain dementia, which I think the two best theories of dementia causation are the dilatory theory and my theory. My theory was neurovascular uncoupling, whereby you have a certain level of metabolic demand in your neuron, and you have a certain level of oxygen and glucose delivery. If you drop the oxygen and glucose delivery by vasoconstriction from sodium, you're starting to create a gap between oxygen, glucose delivery, and metabolic demand. If you further drop the oxygen delivery by vasoconstriction in your cerebral arteries like caffeine, you widen that gap. Caffeine's double bad because it increases the metabolic rate of those neurons. Psychological straight increases the metabolic rate of those neurons, okay? Other stimulants like amphetamines will increase this metabolic rate. MSG, increase the metabolic rate. Aspartame, increase the metabolic rate. The bigger this gap gets, and then if you have insulin resistance, you'll further lower the glucose delivery to that brain cell. Sleep apnea, you deliver it. The bigger this gap gets between oxygen, glucose delivery, and metabolic rate of this neuron, the more likely this neuron is to die, go into apoptosis, programmed cell death. You don't want that. And I actually think this is the most common cause of dementia because this and dilatory theory of chronic cerebral hypoperfusion. I look at brains all the time. I don't see the so-called Alzheimer's pattern. I don't usually see multi-infarct dementia. I usually just see an atrophic brain. Yes, a lot of times I'll just see a bunch of silent strokes, but usually not enough to explain that. And lots of brains are clean and the patient's all demented. When I say clean, I mean it doesn't have any strokes or has very, very few. Okay, so, and the good news is almost all the stuff is preventable. All right. These are just more studies showing high-fat diets will cause memory impairment in mice, learning impairments. And GP is also a neurotoxin. It causes excitotoxicity in the brain. So we didn't have time to go into all that today, but it's bad for your brain. Okay, MSG, this is a lady who cured her kid. She's a biochemist lady, cured her kid of autism by avoiding MSG. Autism is multifactorial. Seneff thinks the main causative thing is this glyphosate. This Reed lady felt the main thing that caused it in her child was MSG, and there's other theories of autism, of course. I've talked about this before, the problems with atrazine. It's also, not only is it an estrogenic chemical that's toxic, it's also toxic to mitochondria. I also talked about soy lowering sperm counts and predisposing infertility. It also can be damaging to the female epithelium of the vagina, damaging to the uterus development, etc. So I'd recommend avoiding it. And I think a lot of the so-called benefits of the soy was simply that same patients that ate more soy were avoiding their meat and dairy. And so what does it all come down to? I think the smart way to live is, to the extent you can, live like Adam and Eve, but keep your indoor plumbing, your indoor heating. And by Adam and Eve, I mean simplify. We're designed to eat three things: starches, fruits, and vegetables. Okay. And you keep your life simple. You get your sunshine, you get your exercise during the day, you spend some time with loved ones. That's about as healthy as you're going to get. And all this fancy stuff doesn't tend to make a whole lot of difference. Oh, and I sort of remember this quote of First Peter. He says, "Well, love is the relationships. Whole food, plant-based diet is the health. Above all, love each other, for love covers a multitude of sins. Use whatever gift you have received to help others." And the point being is that when you're eating whole food, plant-based diet, you simultaneously fix like about 50 metabolic problems. So you don't have to think about it, and be a professor. You just eat that way and you'd be better off. So anyways, that's it.
Now, where did you get that quote?
Oh, what, that last one?
Yeah.
Yeah, that was a Bible quote, First Peter, from chapter in the Bible there. And so I love it. Is above all, love each other, because love covers a multitude of sins. And I think that's truth. I mean, think about the effect of, a mother. The love of a mother just sort of makes everything better for the whole family, for the kid. And it's a powerful thing, I've seen it I've talked about it too. Love is a very powerful thing. It's a very therapeutic. It lowers stress. It makes everything okay. And all kinds of problems are fixed by that love. So, and then I said, for health, whole food, plant-based diet is basically the equivalent. So it's First Peter chapter 4, verse 8.
Nice. Well, you talked about the population that ate 93% of their calories from sweet potatoes.
Yes, that was the Papua New Guinea.
And what I thought was, do they still do that? And I'm just curious, any special kind of sweet potato?
I don't know. But one of the things that was interesting about them was they smoked like chimneys, but they had 6 times less lung cancer than the Americans. And that was because the Americans were eating a high-fat diet. So it was synergistic, more cancer.
Well, speaking of high-fat diets, I don't know if you follow other plant-based doctors, but there's a bunch of plant-based cardiologists now that are promoting olive oil as being good for endothelial function and heart health. And, what do you say to that?
Yeah, I got a bridge I'd like to sell,
Yeah, thank you. Well, people, like Dr. McDougall says, people want good news about their bad habits.
Yeah, basically, I think there's billions of dollars at stake. And if all the, the proles, the peasants, the general public started eating low-fat vegan, that would cause a shift in spending of billions of dollars, okay? So I think what I see is this big, giant corporate push is to get all the poor people, so to speak, to eat high-fat plant-based. It'll free up tons of farmland, but it'll still keep them fat and sick. I don't think the whole olive oil, canola oil is the way to go.
When they ate 93% of their calories from sweet potatoes, what do you think the other 7% was?
I think it was, other local greens and stuff, but I don't know for sure.
Wow, that's so interesting. Have you ever thought of like lecturing at medical schools? I mean, because when you come on, I feel like I'm in school.
I would love to. I wish I wish there was money in it, or I wish I had social connections, which I don't have. Because, for example, when I was in med school, I got 99% on my med school boards, my residency boards. I was actually done with my radiology boards in 1 hour and 10 minutes on a 4-something hour test with a perfect score. And so I love academics and I'm good at it, but there's no one really cares about medical students or even college students. The reason is they show up and they pay their tuition no matter what you do to them, and what I mean by that is there's no competition for excellence. I do great whenever there's competition for excellence. I'll show up and I'll prepare a high quality teaching lecture, whatever. But what the colleges typically do is they take the professors who are ready to be put out to pasture. You get all these professors that are no longer doing good research, and you go, okay, you guys teach the medical students, and they don't care about it, and no one really cares about it. And then the next claim that's typically made in a college or an academic medical school environment is that teaching is a parity product, meaning that all teachers are the same and that you just go by the book. But that's not really how you learn. We all know we've had a few teachers in our life that were just really good, and we learned so much faster from them, and it was so much more fun. So I would love to teach at a medical school. I would love to. I wish there was some. Well, you know, we got, like I said, your YouTube channel is basically the School of Athens for modern learning. It is. And
well, you know, it's not true that no one cares about medical students, because are you familiar with the work of Dr. Michael Clapper, Moving Medicine Forward? He's doing things in the medical schools.
well, I'd love to see it happening, but I just know from my own personal experience, novelty is not really welcome. It's almost like a dogmatic religion. Nothing should ever change. It's weird, but that's kind of how it is. And I also, not to brag, but I'm a little bit intimidated, I think, because I'm not just like AOA top 10%. I'm like, you know, the best, okay, in terms of like academic ability and teaching skills. And I've written several books on study skills. I always think that's kind of funny. It's like, if you want your students to have the highest board scores in the nation, hire me and I'll help them, okay? But no one really cares, okay? I had a funny experience too. When I wrote a study skills book, I sent letters to like 200 high schools because I figured, oh, they'll be so happy I can help them to crush the SAT. You know what? Only 3 of them sent me a response and they said, they'll get back to me. Not a single one invited me. I offered it for free, you know, because I was kind of in the mood for all the study skill stuff. Because basically, all these kids go to college and they pay all this, you know, buku tuition, and none of them knows how to study. Everybody thinks they know how to study. They do what they did in high school. They highlight their notes. That's not really advanced studying. I'm talking about, I studied what all the memory champions do. You can really increase your IQ about 30 points. And if you're going to pay all that tuition, why not learn study skills? Every grade school and high school should teach study skills, and they don't. None of them do. I've never met anybody that knew this stuff. I met one guy who graduated first in his medical school class, and him and I had a real interesting conversation. He had gotten really good with flashcards, and there's a lot of flashcards, spaced interval repetition systems that are interesting, but I think you know what I mean.
Well, I don't know if I'm learning anything these days, but I would take a course like that if you offered it. That sounds really intriguing. Are your children good students?
My children are good students and they're bright, but there was a little bit of a discrepancy between my wife and me because my wife is a doctor. She's more of like your typical doctor, okay? And there's also the most common attitude you get amongst parents is, well, you go to school, you get good grades, and then you get a good job, and you make decent money, and you have a decent house, a decent life, and all that. That's nice. But I would say I'm more almost like aesthetic about it, like artistic about it. When I grew up, that was part of being a man. My dad's brothers would come over, the uncles, and they'd all talk about books. I wanted to be like them. I really admired my father. He wasn't home much. He was working all the time. He had been an athlete when he was younger, so I wanted to be like my dad, okay? And so for me, reading and talking about books, it was like an enjoyable, pleasurable thing. And there was like an aesthetic beauty to it. And also, it's almost like I felt in my own mind that I had ruined my own life by kept getting repeat injuries, trying to come back too soon after my athletic injury. So I had this idea, I don't want to just be a doctor. I want to be a great doctor. I want to do something great and wonderful and beautiful and all this stuff. And so what I'm trying to say is, like, for example, I had my kids all take drawing classes and they got pretty good at their drawing. But then my wife and her family got scared. They're like, you're going to turn these kids into a bunch of bohemian artists. They're going to be starving, okay? None of this, don't be so crazy about all this art, but I love all this art. You've seen how I love the art and the painting. So what I'm trying to say is when you start going beyond convention, people get nervous. They're not used to it. And I go beyond convention all the time. So I find myself very often having to sort of close down and not say what I really think because my opinions and ideas quite often don't fit, you know, the normal distribution curve. So what I'm trying to say is the kids sort of had my influence, but I was working a lot. I was an imaging guided surgeon. I was covering 3 hospitals. I'd be coming home at 9 o'clock at night a lot of times. So the wife, the mother-in-law took care of the kids more than I did, the wife's family. And initially the kids took up my stuff. And then the wife kind of freaked out a little bit that I'm too of this artistic. She said, oh, you're crazy autistic. And then when the kids got a little older, they started coming back to my ways. You know, they went to high school. I was working a lot. And then when they started coming up against some of the more difficult science classes, they're like, wow, this class is pretty tough. Maybe I should ask Dad. And then I would help them with the classes. And then they started liking it. And I also had a funny thing with my kid. One of my sons was in college and he's taken a writing class. Okay. And I had him write a paper about low-fat vegan diet for diabetes. And his teacher was this big fat guy. And the kid did a real good job in the paper. And he got like a B- on the paper. He's like, Dad, I got a B-. And I go, yeah, the teacher's treating you unfair. It was a good paper. And the kid did a lot of work on it. So anyways, the kid didn't kind of talk to me the whole rest of the semester. I was working a lot. And then I go, how'd the thing go? And he goes, oh, the class went fine. He did well in the class. I'm like, well, who was helping you? Who was proofreading your papers? And he's like, oh, yeah, my sister. His little sister was in 8th grade. He's in college. And I'm like, she's in 8th grade. And he goes, Dad, he goes, I don't want to hurt your feelings, but it was better for her to help me than you. He goes, you don't understand college professors. She said, you don't think like a college professor. She does. And I'm like, well, that says more about your professor than it says about me. Okay. That an 8th grader thinks like his college professor. Okay. She's not a literary genius. She's just a regular kid who reads a lot. All right. And it was kind of funny, but that's kind of what I'm getting at, has been my experience a lot of this whole process. But as the older my kids got, the more they're like, hey, dad knows what he's talking about. And I go, you're going to see this, that the older you get, the more everything I ever say is going to be accurate and true. Okay. If it seems like it doesn't match what you heard at your high school, that's because I'm right. Okay. But it takes a little while for that effect to happen.
Yeah, that's funny. I do like your pairing of art and science. Maybe you can write a book about that.
Yeah, I think there's a lot of connection there, and there's sort of an appreciation for aesthetic beauty that leads to a lot of good things. For example, when I took biochemistry, I was like, this is the language that God uses to write the book of life. And I love biochemistry. That's how I got so great at it, because it was just a joy for me to study biochemistry. And that's kind of what I also talk about too. If you talk about two young people in love and they're obsessed with each other, oh, I love the way she talks. I love the way she walks. I love the way she interacts with her family or siblings, blah, blah. Yeah, young guy in love talking to his buddy about a girl he's in love with. And the point I'm saying is, if you could learn to love biology that way or biochemistry that way, you'll get great at it. Because it's been said too, in order for a man to become great at a complex subject, he must love it in order to go through all the detail of learning the complexity. And so I actually believe there should be a lot more of this type of talk in an academic environment, not just trying to get people to memorize these long lists of stuff, then they forget it as soon as the test is over, but rather showing them this is aesthetically beautiful. This is interesting. This is a fundamental concept which explains a lot of things. You know what I'm saying? Sort of a holistic perspective, if you will, versus what tends to be done as a reductionist perspective. Kids are given this long list of things to memorize. This is very typical grade school and high school, and they memorize it for the test. And then the kid and the teacher know that they're going to forget it a week later. And you know what that reminds me of? You ever remember the movie Cool Hand Luke, where Paul Newman, they go, okay, he tried to escape. So as his punishment, the warden says, okay, you got to dig this ditch. All right. So he digs the ditch. He says, now you got to put it back in. You got your dirt in my spot. And the other guy comes along and says, you got your dirt in my spot. The point I'm saying, it's like a punishment to have to take all that intellectual effort to memorize something that you're just going to forget. It's a waste of time. Whereas good learning, true learning about the vegan diet to be healthy, we want to keep that information. When we learned how to drive, we remember that the rest of our life. Learning how to talk to girls, you remember that the rest of your life. Learning how to dress, you remember that the rest of life. Good, useful information, we remember it. It's the silliness, vocabulary words for a test that we don't care about.
Yep, absolutely. So you had mentioned earlier in your talk something about your 10 commandments. You should write them all out.
Actually, I did write a set of vegan 10 commandments, and they're kind of funny. They're things like you'd expect. Thou shalt not eat meat, thou shalt not eat oil, that sort of stuff. And I had kind of fun with it because I do think that's highly relevant in the sense that social thinking is good for social stuff. Go with the flow, everything in moderation. When in Rome, do as the Romans do. But when you want to talk about health, and you want to talk especially about nutrition, it's this biblical thinking that works. Like an alcoholic. You don't tell an alcoholic you can drink beer on Saturdays. No alcohol. Cigarette smoker, no tobacco. And these fixed health, also, I know that too, like I've seen people who become very successful at something. They make up their mind, they make their goals are clear, and they follow them. And it should be the same thing with nutrition. Thou shalt not eat meat, thou shalt not eat oil, etc.
Right. What do you next time, will you share all 10 with us?
Yeah, sure. I'll include those next time.
Nice. Okay. Well, a few questions were sent in advance, to you specifically, if you don't mind answering. This has to do with academics, actually. This one from Cindy. And she says, Dr. Rogers, in the special education school with special needs students and behavioral problems, they get lots of Skittles and M&Ms for reinforcement for good behavior. I've seen students' behavior go from good to bad. The teachers don't seem to see how this is related. The lunch are all processed, horrible foods. Can these candies and foods contribute to bad behavior and learning disabilities? And what would you recommend instead?
I'm laughing because of course they can. For example, you can go back to the 1970s. There was a Dr. Feingold, an allergist, and he had a Feingold diet with good results for treating children with hyperactivity. Okay. There's lots of chemicals in these processed foods. The food dyes themselves can be SERCA inhibitors, sarcoplasmic endoplasmic reticulum, ATPase inhibitors, which can cause problems in cognitive function. All right. Also, we just talked about glyphosate, GP in the non-organic foods. That itself is an excitotoxin. So that means it causes overactivation of brain cells, something that causes overactivation of brain cells, meaning increased release of glutamate, the excitatory neurotransmitter. Psychological stress also does that. That can make a person anxious and hyperactive in their behavior. All of that stuff is bad. And then there's a whole bunch of these chemicals in the food dyes, also in the preservatives, BHA, BHT, all this stuff. They're all potentially neurotoxic. And then how is the protein processed? The soy, quite often with hexane, that's a neurotoxin. How is, gosh, it goes on and on. That's a very bad idea. Plus, you're teaching children that the reward is junk food. That shouldn't be what you teach children. And also real learning, it's a pleasure to learn real stuff. When you think about something you're looking forward to hearing, let's say you're excited about a Dr. McDougall lecture, you want to hear the lecture. No one has to give you Skittles to listen to the lecture. You want to hear that information. So what I'm trying to say is good learning, if they were sharing the children's time, no one has to give children Skittles to get them to go to play their sport that they like, I can remember when I was in grade school, I was a little bit hyperactive. I was suspended from school and I was put into a special platform. That's because I was smart. I do the homework in 5 seconds and I joke around with my friends, So they put me in a pod where I'm by myself. I'm lucky of this. They would have drugged me. They would have drugged me and caused brain damage. I'd be a chronic psych patient if I hadn't. Lucky if it wasn't before the drug days. So anyways, my mother made a deal with me. She says, I don't want to get any more phone calls from this school. She says, let me tell you something. She says, if you want to ride to wrestling practice, no more trouble at school. You hear me? I'm like, all right, Mom. So that kept me out of trouble for about 3 years.
That's funny. You remind me of Dr. Alan Goldhammer. You have to meet him because him and Dr. Lyle were so smart. I know a friend of theirs from high school, and the teacher said, listen, I'll just give you both A's if you just go outside and play basketball. She didn't even want them in the class because they were so smart. That's funny. Okay, we got a couple more questions that were submitted. And this one is, she says, my lab results routinely state several times throughout the report, sample icteric. Some results may be affected. She wanted to know what that means. And is it because
when I think of the word icterus, I think of yellow, I think of jaundice. But sample icteric, I'm not sure what it means in that context. Do they mean high bilirubin or something? I don't know. She
wondered if these were unreliable, so you don't know what that means.
It was a blood test?
Yeah, what that means. It says
I'm just guessing. Maybe you lysed the red blood cells and now you got sort of like a high bilirubin effect in the blood or something, but I don't know for sure.
Okay. Yeah, because you don't look at a lot of blood tests in your.
No. I primarily work I used to be an imaging guided surgeon, and now I primarily work as a neuroradiologist, and I sort of like nutrition. Okay. So those are sort of the main things I do. I mean, I do general radiology. I still do some imaging guided surgery, but not that much. Neuroradiology would be my main focus these days. And partly where this all came from was I would see all these demented patients and I wanted to start really understanding. And then I read all the Alzheimer literature, and it was a joke to me. I'm like, Alzheimer's to me sounds stupid. When I say stupid, I'm like, let's say somebody comes with Alzheimer's. What's the key historical finding? There is none. What's the physical exam finding? There is none. What's the blood test? There is none. What's the reliable imaging finding? There is none. What's the reliable autopsy finding? There is none. What's the treatment? There is none that really works. So you got no way to diagnose and no way to treat, and you're going to claim that that's an important disease? Sounds a little bogus to me. So anyways, but what I'm getting at was that led me to then say, well, I see all these patients, all my demented patients, they're all 95% of them are diabetic, 95% of them, they're hypertensive. So I'm like, I want to understand these diseases. That's partly how I started to read in all this detail and all this stuff. Anyways.
Thank you. This is from Diana. She says, Dr. Rogers, can small vessel white matter ischemic disease seen on MRI be reversed with lifestyle interventions? And can you explain the symptoms associated with the disease?
Yeah, so what that means, those are often called silent strokes. When you look at a brain MRI, you'll characteristically see bright spots on what's called a flare sequence. A flare sequence is like a T2 suppression sequence. So what that means is in MRI, there's basically, if let's say you're talking zoology, there'd be animal kingdom and plant kingdom. In MRI, the equivalent is T1 and T2. On T1, fluid is dark, and on T2, fluid is bright. Okay, but then if you're looking at a brain MRI with bright fluid, it can be like squinting into the sun. So you can do a trick on MRI where you suppress the fluid, and that's called a flare sequence. So a flare sequence is still T2 weighted, meaning that it's a T2-like sequence, but you suppress the CSF so you don't see the cerebral spinal fluid in the ventricles or in the sulci. And then you can see all these subtle little strokes, what she's talking about here. And yeah, people tend to have lots of them. After 55, the majority of patients have some. But I see plenty of people who've got a clean brain with none of them at 85 years of age. So if you have got good health habits, you're unlikely to get those. And if you do have them, you want to optimize all your health habits. What do I think are probably the most common screw-ups? Well, first, of course, is to get the diet right. We've talked about how to get the diet right. Low fat, low sodium, 100% vegan. Okay. But then the question is, how else can you still be screwing up? Very common way people screw up, I think, is they overtreat their hypertension. And I think Dr. McDougall has good lectures on this. He won't treat their hypertension unless it's repeatedly, systolics over 150. And what am I getting at? I think a lot of people push their systolic too low by over medicating themselves, and they end up like Delatorre's mouse, a mouse equivalent, meaning chronic cerebral hypoperfusion. Why does our blood pressure go up in the first place? Because when you stand up, the hardest place to get blood is to your brain. You have to pump at a high enough pressure to adequately oxygenate your brain. Your brain's the number one priority of the body. So if you're driving your pressure down artificially to an excessive amount by medications, you're chronically hypoperfusing your brain. I think that's a dangerous thing to do. So you don't want to overtreat it. You're creating a mouse equivalent. Delatorre would tie off the mouse's carotid, and about 2 months later, the mouse would be demented. At autopsy, there was no stroke. There was just an atrophic brain. Chronic cerebral hypoperfusion leading to apoptosis, programmed cell death of the neurons, whereby they recycle themselves, so you don't see anything on the MRI. So what I'm basically saying is, just like Caldwell-Esselstyn reversed all these patients with coronary artery disease, if you optimize blood flow to your brain, it will work as well as it possibly can. And that's the smart thing to do. You don't often see silent stroke reverse itself. So it's probably not going to revert to normal on your brain MRI, but by improving the perfusion of all your neurons, you get the best possible function. Plus, I do think there's probably a component of what you would call, in the heart, we have something called hibernating myocardium or stunned myocardium, meaning that there was ischemic heart muscle that's not functional due to a lack of blood supply. But if you improve the blood supply, it can be restored to normal function. And I think you have the same thing in the brain, that some of these silent strokes are these chronic periventricular ischemic changes. They're not necessarily irreversible initially. Plus, you've got a lot that sits in what I would call a penumbra phase. Penumbra means twilight. So, the transition from afternoon into night and stuff that's sort of half there, half not there. And once you optimize your blood flow, I think you got a good chance to get those neurons to function again. Plus, everything is going to function as well as it can. And once you get rid of all this junk food and processed food and caffeine and stimulants and stuff, your brain just starts to function more clearly. And that's what you want. I noticed too, I went through a health problem phase in my mid-30s where I got real fat. I was total workaholic, working too much. And I would sometimes get brain fog. I had pain in my feet when I woke up in the morning, a little bit of a peripheral neuropathy of some sort, and all these weird little back pains and stuff. Once I went vegetarian, all that stuff went away. And now I'm 59 and my brain's as clear as it ever was. And I'm really grateful for that. And I think it's because of, this healthy diet and lifestyle. I'm real simple. There's only 3 things I eat: starches, fruits, and vegetables. That's it. And I take a B12. That's it.
Great. Thank you. There's a question from Jane asking if there's any room in your Spartan diet for fermented soy foods such as soy sauce or natto, or for very low-fat fermented pea protein powder, because adults over 65 need to increase their protein intake.
Okay, well, that's a couple questions there. And I'm just going to let you know also where I'm coming from. Okay. Where I'm coming from, I'm a little bit of an egomaniac, just so you know. Okay. What I mean by that is I don't want to be okay. I don't care what regular people do. And also, this is a little thing that was a little bit of a disagreement between my wife and I. I would say, well, look, I want the children to develop an interest in these things. And my wife will be like, a 4th grade kid doesn't need to know PowerPoint. Okay. She says, you're autistic. You don't need to do all these things. I just want the kids to be normal. And I said, I don't want them to be normal. I want them to be the best they can be. And what I mean by that is my goal is not to just have adequate brain function. My goal is to be the best I can possibly be. I believe I'm one of the best doctors in the world, and I want to continue to be one of the best doctors in the world as long as I can. And if somebody doesn't agree with that, that's fine. That's okay. My own view of who I want to be and where I want to be, I push for being the best I can possibly be. I want optimal cognitive performance. I've studied a lot of great authors and seen their quality decline as they move from their 50s or 60s and their 70s. Whereas I've seen other authors who kept it together and still write in an excellent fashion in their 70s and even 80s. And what I'm trying to say is, if you want excellent, optimal performance, you have to pay attention to all the details. And I actually think that's one of the big differences between me and a lot of other nutrition experts is I'm interested in the brain more than the heart. For most nutritional guidelines, the idea is let's just prevent a heart attack. That's the most common cause of death. Keep the arteries open to the heart. My attitude is much more meticulous than that. I don't want any of these stimulants. I don't want any of these circuitoxins. I don't want any of these excitotoxins, any of this stuff, heavy metals causing neurodegeneration. So I actually think soy is a bad food. Okay. I'll flat out say it. I recommend zero soy. Avoid it. It's thousands and thousands of times more estrogenic than other foods. The vast majority of the soy that's market available is GMO, sprayed with GP, quite often processed with hexane. The small amount that the Asian population used to eat was like grown in their backyard, unprocessed or only minimally processed, locally processed, not this industrial stuff that's widely available today. There's lots of studies showing problems. I recommend avoiding anything with soy in it, is my feeling. So that was, I answered the soy question. What was the other part of the question there?
Natto and soy sauce and pea protein for seniors over 65 that need more.
Oh, I think that's bogus, this idea of seniors need all this protein. We get far more protein than we need. There's been populations where they fed starving people 2.5% protein and they did great. There was also, look at Kempner. He was feeding people about 4.4% of the calories from protein. Okay, and they're doing really well. All right. We eat way too much protein, and there's all kinds of funny things, like look at the Bantu women. Okay, they ate this minimal amount of calcium after having 10 or more kids. They don't have any problems with osteoporosis. It's the American women, especially the ones drinking milk and dairy with the high protein intakes and the high dairy intakes, the high animal proteins, that have all these problems with osteoporosis. Okay, I think it's a lot of things get put into the public mind to sell stuff. For example, you should drink 8 cups of water today. I never heard that before. And I was an athlete. The marathoners used to not drink any water, up until the early 1970s, winning the Olympic gold medals. So what I'm trying to say is, once they started selling bottled water and Gatorade, all of a sudden, everybody needs to be hydrated. You need to drink 8 cups a day, And so what I'm trying to say is, I'm not buying this new stuff. There's always some new trend that everybody wants to do. I used to see all these fat women walking around with these giant liter full of water, sipping on water all day. And none of them ever lost any weight, but it was psychologically, it made them happy. They thought, if I just drink water all day, I'll be skinny. So I don't believe that stuff. Have I studied it in detail? No, I have not. But just the sound of it sounds bogus to me, like a way to get people to buy more high protein, high fat foods.
Yeah, and if people want to see your opinion on soy, you did a whole talk on that before on this channel. And then, okay, so you answered about the pea protein and whether or not women over 65 need more protein.
Yeah, I think it's bogus. I think.
So how do you feel about mushroom powder and maca powder?
I don't have any experience with it.
Okay, terrific. And there's one more, I think. This is about green tea. She says, we know you don't consume caffeine or advocate its consumption, but what about matcha green tea? Research shows beneficial anti-cancer effect. Don't they outweigh the negative effects of the caffeine?
Yeah, I think anytime a food product is popular, there's almost always a whole bunch of industry-funded things that say it's good for you. It's sort of like caffeine. There's tons of industry-funded information saying it's all good for you. And I can tell you, I got all these doctor friends who thought caffeine was good for them. And I can remember when I was young, it was like the cool thing to do to have a cup of coffee. But when you sit down and you ask yourself the basic science of it, well, gee, caffeine increases the same hormones as psychological stress, catecholamines and cortisol. We all know there's a lot of harmful problems with psychological stress. So caffeine can't be good for you, okay? And what I'm getting at was tea. Tea concentrates fluoride. It has a tendency to concentrate aluminum. Some of them concentrate tea. Maybe they got a special brand that's less likely to do that. There's a good book. I think I got it around here somewhere. I know I had it in my room somewhere here. This guy, Food Forensics book, where they tested all the stuff. And, maybe you can find a brand that doesn't have it, but a lot of teas concentrate aluminum, fluoride, and some of them concentrate lead too. So maybe that's a little bit better than the other one. Plus, caffeine is not a healthy thing. So, I would avoid it. A lot of tea is really well marketed. I got, like I said, people in my family that would drink this Earl Grey garbage tea that they would say to me, oh, no, this is good. You don't know. And I'm like, yeah, right. What would I know? I study the stuff. I love you. And I'm trying to tell you the truth. You don't listen to me. You listen to some commercial. Okay. You just failed your instant IQ test. I wouldn't bother with it. I kind of doubt that there's some significant benefit from it, but do I know for sure? No, I don't.
Great. And here's the last question. What is the best plant protein for longevity?
The best plant protein?
Yeah.
Oh, well, I don't think of stuff specifically like that, but here's how I think. I want to minimize my dietary fat and I want to minimize my dietary protein. So why is rice, potatoes, and sweet potatoes so great? Because they all have about 1% fat. Why do I think sweet potatoes are the best food in the world? Because they have about 4.5% of their calories coming from protein. So you simultaneously have a markedly low protein and a markedly low fat in a sweet potato, and they taste great. What more could you want? And potatoes and sweet potatoes are very highly nutritious. So you get all nutrition, you get great taste, and you minimize the things you don't want. I want to minimize my dietary protein. So those are, I think, the three great foods. Rice has about in the ballpark of, depending on the rice, I've heard all kinds of numbers. When I've looked it up, I get about 7% of the calories from protein in rice. The fat's about 1%. I'm talking about white rice. With potatoes, it's about 8 to 9% of the calories from protein. And those are also relatively nutritionally complete, the potatoes and the sweet potatoes. So
That's
the
what
question
I
again
eat
was,
every
what I
day.
think is the best protein? Yeah, I would say sweet potatoes.
So you only eat one meal a day though, right?
I usually only eat one meal a day if I have to work that day. And it's mostly because I want to save time. It's just convenient to come home and eat a big dinner. I would also say, like, in a perfect world, let's say I could do whatever I want. I was rich. I owned a house on a hill with a big lake next by. I would just eat a late lunch every day. The reason I say that is you don't want to eat first time in the morning, because morning is what I call brain time. I'm always trying to do something challenging.
Okay, and I agree with you for me, but I keep hearing from these doctors, especially the Adventist doctors, breakfast like a king, lunch like a prince, dinner like a pauper. And the oldest doctor I've had on this channel, who's almost 100, never eats dinner. So, I mean, I'm not disagreeing with you, because I can't do no dinner. I can't eat breakfast. I just be nauseous eating that early. But why are they saying for circadian rhythms and everything to eat? I agree with you is what I'm saying, but other people think differently. So tell me why.
Well, there's 3 times you could eat. Let's say you could eat in the morning, you could eat in the lunch, or you could eat in the dinner in a sense. So morning, afternoon, or evening. And what I think probably biologically seems best to me is probably to eat in the afternoon. But the reason I eat at dinner is because I got to work. I come home from work at night and then I eat my dinner at night. And the reason I don't eat in the day is because I save a lot of time by just eating one meal a day. But let's say I had a couple of days off in a row, I will typically eat a big lunch, a big late lunch. And the reason is when you first wake up in the morning, you get this cortisol surge. And so you're usually not hungry. All this stuff about you have to eat breakfast, that came from commercials from the breakfast food companies. Okay, I don't think that's a legitimate real thing. And you're smartest in the morning because when does an animal need to be smart? An animal needs to be smart when it's hungry. So break fast after you've fasted overnight. Your body's designed to be smart in the morning. Your brain has cleaned itself overnight through the glymphatic system. Your neurons can't go offline in the daytime while you're awake because they have to maintain precise neuronal gradients, ionic gradients. So you accumulate neuronal waste products through the day, and your brain becomes a little more clouded and sluggish and slow as the day goes on. So what I'm trying to say is, if you're an intellectual person and you want to do creative work, you want to make YouTube videos, you want to write book chapters and whatnot, you do that intellectual work. You want to read complex journal articles. You do that in the morning when you first wake up. That's when you're best at doing it. And then as soon as you eat a meal, especially if you eat a moderate or big meal, you get kind of sleepy. Your IQ drops about 20 or 30 points. So I want that precious morning time for cognitive work, and the fact that I'm not hungry to not be affected by food. Then to take a study break, I'll often eat a big lunch. Let's say an OMAD diet when I eat a big lunch in the afternoon, let's say around 2 o'clock or something. And also because I want to go outside and get some sunshine. And I'll walk around while I'm eating and I'll get sunshine. So that's ideal for me when I got control of my time. When I don't have control of my time, I got to work all day, I'll eat the OMAD diet at night. The benefit of eating in, let's say, for a lunch meal is because, number one, your fluid status of your body normalizes. After you eat a meal, you're kind of overloaded with fluid. So if you do that at night, you have to wake up the void, you don't sleep as well. Versus if you have that meal at 12 noon, by the time you go to bed in the evening, your fluid status is evened up, so to speak, and you're going to have to void less at night, so you'll sleep more fully through the night. I'm actually getting in the habit of liking the temperature warmer at night than I used to, because then I'm less likely, maybe if I sweat a little, I don't care. I'm less likely to have to wake up the void, and I'll sleep more thoroughly through the night. So what am I basically saying is, I think in a perfect world, it would be great to eat twice a day, sort of a little bit of a late lunch and maybe a little bit of a late dinner, but the big meal in the middle of the day. But for practical purposes,
a little bit of a late dinner. You want the dinner late?
Well, if I'm going to eat twice.
Yeah.
Because if you're going to eat twice, you can't eat 2 meals close together. You're not hungry. But what I find myself doing let's say I get 3-4 days in a row off, which I sometimes have, I will find myself preferring to just eat one lunch anywhere from noon to 3 o'clock. And that'll be my big meal for the day, because it just fits my day. But I'm not saying it's necessarily healthier, but I don't think there's that big a difference. And the only thing that really matters to me is that I wake up less frequently to void at night, because then I sleep better.
Yeah.
But other than that, I don't think the other things matter that much. I know the Romans, like the Roman soldiers with the ancient Rome, they used to work all day when it's light out. They didn't have any electric lights, and they'd eat a big meal at night and go to sleep.
Yeah, well, you're so fascinating. If your wife thinks you're autistic, why'd she marry you?
Oh, I'm like the perfect husband. You know, the old joke was the perfect husband to marry is a surgeon because they work all the time and the wife just spends their money. The way my wife looks at me, I think is like her robot. Okay. I'm a robot that makes money for her. Okay. People think, oh, being a doctor is so great. Yeah, right. Work all they're workaholics. They work all the time. You're tired, you know, and then you just want to sleep and read on the weekends. I don't do much. But people say, "Oh yeah, isn't it great?" And I'm like, "Yeah, right. A lot of work. The medical system is like a factory, if you will. And a doctor's job is to generate billing codes. You know, you try to help the patients as much as you can, but in general, you just follow the standard guidelines that keeps you out of trouble, gets the work done, gets you paid, and then you sort of add in this aesthetic part. Like for me, I love whenever I get an interesting case or I have an interesting idea, I call one of my buddies and we have a computer system. We can look at the cases together and we have a lot of interesting, fun discussions of the cases. Plus, you know, we'll talk to each other about our own health issues and stuff. You know, I got some older doctor buddy friends and they'll always be asking me, well, what do you think of my cholesterol? What do you think of my wife? She's got diabetes. She's got, you know, kidney function, renal failure and stuff. And then also I got a lot of doctor friends. They'll come by and talk to me through the day through the complex cases. So I'm known for being really smart at handling complex cases. So I enjoy that too, because that's stuff that's already filtered through the normal system. When they come to me, it's because they haven't been able to figure the case out. So anyways, that is the more you like having things that sort of challenge you. You know, if a person, you know, can do two different things, they tend to enjoy the thing that's a bit of a challenge. We get it's enjoyable for us to have an intellectual challenge. So I like that kind of stuff. But that's like I said, some people say, oh, how could you talk about your wife? You know, my wife has it so good. I wish I was married to myself.
I'd love for her to come on sometime. I think
That's what my wife would say. My wife would say, why are you doing all this nutritional stuff? You don't make any money for this. You could be out moonlighting, making a lot more money for a family. I go, yeah, right. I'm already working 5 days a week. I'm half exhausted. You want me to work on the weekends too? No, I'm going to enjoy my days off.
I think you're fascinating and you're certainly never boring. When you're eating your one meal a day, though, how do you, I mean, that just seems to me to eat only one meal, you'd have to eat such a huge quantity to get enough calories.
Well, a couple funny things about that. I have a big bowl and I've been teased that my family calls it a Shrek bowl. And you know, sometimes I'll watch internet videos while I'm eating. Other times though, especially if it's my afternoon, it's warm outside, I'll go walk outside in the sunshine. I like that. I get my sunshine, all the benefit of that. And I get some exercise too. So that's all positive, but I don't have a problem. Usually I'll eat the starches first. It'd probably be smarter to eat the greens first, but I typically eat the starches first. It'll be something like rice, potatoes, sweet potatoes, and some beans. And then afterwards, I'll have some fruits, you know, blueberries or something else. And then after that, I'll have a salad, and that's a pretty typical meal.
And that's it. Oh, so you eat kind of in reverse calorie density almost.
Yeah, maybe because like we're kind of programmed to do that. You know, I've seen your interviews with you know, with Lyle and whatnot. Our body can sense the caloric density, but from a health point of view, it would probably be healthiest to eat the salad first. But I feel pretty good, you know, so. I'm not, my weight's good. My energy's good when I lift weights and stuff. So I'm just.
Do any exercise other than weightlifting?
Yeah, I walk up a lot of stairs. It's kind of like partly I have to, and it's partly there was also a thing in the marriage. You know, what's the secret of a successful marriage is that it's separate bathrooms. Okay, so I had to negotiate who gets what bathroom with the wife. And one of the secrets I learned in negotiating with the wife is no matter what happens, you have to always act like you were disappointed with the result. And what I mean by that was she wanted the ground floor parent bathroom. I'm like, okay, fine, you could have it. You know, and I acted like I was disappointed, but the truth was that's exactly what I wanted. And here's the reason why. All day long, I constantly have to go from basement to upstairs, all day long. I get tons of stairs every day. It keeps me in good shape. So that's what I wanted. At the same time, though, you have to act disappointed because that way she thinks she owes you a favor. So for whatever comes up next, you know.
Does she watch any of your presentations?
I don't think she watches too many of them. Like I said, I think she kind of thinks of this whole nutrition thing as a bit of a joke. It's kind of like, why would you, who could make so much money moonlighting for this family, be messing around with all this nutrition silly stuff? Okay, fine. You're a vegan. Okay, isn't that enough? Why do you have to study every last thing? You're so autistic.
Oh my God. I want to meet you. You got to introduce me to her. Maybe before we go on next time. This is fascinating. Like, okay, so you eat really clean. Like on your birthday, do you eat, and I don't mean like a standard cake, but do you ever eat anything a little bit richer or more decadent, like once a year?
I don't have any cravings for any of that stuff. My craving is, you know, I wish that I was smarter. I wish I could think faster. I a lot of times I'll be like obsessing about something, trying to understand something, whatever it might be. What really causes insulin resistance? What is the main cause? What are the secondary causes? I figured out the main cause, but what are the secondary causes? And I'll be thinking about it, and sort of like food, I enjoy my food, but it's not like a high priority for me. Sort of what'll make me have a good day is if, if I talk to a friend, or if I figure something out that I've been trying to understand for a while. The food, I enjoy it, but I don't know, it's not that big a deal to me. I'm very happy with what I eat. What I'm trying to say is I don't have any cravings to do anything different. Plus, I know all the consequences of what I eat. So I just want to eat healthy. I know what to do. I do it. And and because that's another thing people say, oh, well, don't you want, beer and pizza? You're missing out on life. And I'm like, you know what? I'm quite happy with how I am. I have no interest. I went through a fat phase. I didn't like it. I don't want to go back there. I don't want to plug up my arteries. I don't want to cause excitotoxicity in my brain. Everything is fine. I'm happy. Okay. That's not.
Well, that's great. Well, because would you eat a Chef AJ dessert that's very low calorie dense, made with just
if it's something you made, I trust you. But you know what I'm saying.
Okay. Well, Dr. Rogers, you are fascinating. Thank you so much.
Thanks.
And thanks all of you for watching another episode of Chef AJ Live. Please come back tomorrow for Lauren Bernick with Plant-Based Classics.